Ahoy hoy, I am Planner Walk, and welcome to another stream. Where we're going to be discussing the issues with Ken Wheeler. Certain problems that I've found that Ken Wheeler has, right? As well as, maybe going over some of his content, or actually we'll look at some of the comments that I've received on some of my videos. Because I don't want to just constantly make videos about all the comments that I get. And ahoy hoy Paul's heart attack support, how are you doing? So, I think there's things that I should mention. Oh, yes. So, if you disagree with what I'm saying, I invite you to come on. I mean, it's something that I actually made I should have actually mentioned it in my last video. I had it uploaded and everything. When I posted my last video, I had it uploaded and set as a premiere. Then I realized, oh wait, there was something that I was meant to mention. I do that so often where I just forget to mention something in a video. You're doing good? That's good. And ahoy hoy Q Continuum. How are you doing? I'm gonna have to get used to seeing you as Q Continuum, not funnily enough, not Walter Van Bellingham. Not Van Bellingham. Van Bellingham. And ahoy hoy Judy Bassett. And let me just bring up. And kia ora, NZ Pure. Let me just bring up Firefox because here we go. So, let me switch to this thing here. Yeah, that's the right one. I was thinking, I thought I had switched to, I think it was this one here. But no, I switched to this one here. And so, yeah. Let's go over some of the comments because I got some interesting comments, and I've changed it so that it's ones that I haven't applied to. I actually got this one here. This is saying, this is the first video of yours that YouTube suggested to me. No idea who Ken Wheeler is, by the way. Gonna take a look at this anyway. And so they said that I think watching Thunderfoot got me here. And yeah, Thunderfoot is actually one of the people that is on my... When I go to the... something in analytics... Let me just get that off there. Go to audience. Okay. Bring that back. So. Yeah, go. Oh. Ah! What are you doing? I know what. YouTubers can be really annoying. Okay, here we go. Alright, other channels that your channel watches. So we've got Simon Dan, obviously, Creaky Blinders, Sick, Irish Demon, Professor Stick, Viced Rhino, and Thunderfoot, Logic, Professor Dave Explains, Emma Thorne, and Schrodinger's Cat, rest in peace, Paul Agier, Godless Engineer, Telltale and Aaron Ra. So yeah. Maybe I need to do collabs with Sick, Irish Demon, Professor Stick, Viced Rhino, Thunderfoot, Logic, Emma Thorne, Paulo, Godless Engineer, Telltale, and RNR. Gee, I haven't even collabed with it. I've only collabed with 1, 2, 3, 4. I've only collabed with 4 of the people on there. That's less than 33%. Anyway, fun little tidbit for anyone that was wondering. Alright, so NZPure asked, is Godless Engineer still around? None of his content has popped up for me. And yeah, he's still making content. Don't know how his channel is doing. Let me actually check. Yeah, he's getting a decent amount of views. Not sure if it's as much as it once was, but Miko Watch said half of those are religious related channels, so if you want to get that sort of audience, it would be a little bit of a change, wouldn't it? Yeah, well, I do have a video planned about Matt Powell. And that's going to be an interesting one, because Creaky made a video. And then I saw Creaky's video on the subject. I realized that there's one thing that Creaky didn't really mention. Well, he mentioned, but there's one issue with Creaky's video, and that's the fact that it was Creaky, right? Now, I suppose that I appreciate Creaky's opinion as someone that doesn't really play video games or watch Marvel. Did he say they watch Marvel movies? I can't remember. But, doesn't really play video games or watch anime. And as someone who does play video games, watch anime, watch Marvel movies, all that kind of stuff, all that good stuff, I think that I have quite a few opinions. Trace D says, watch this link if you know what's good for you. You're probably not able to post that in chat because chat likes to block links. If you want me to watch a link, you'll probably want to send that to me on Discord, and there is a link to my Discord in the description of the video. Or the description of the stream, should I say. But yeah, I am going to be making a video on Matt Powell. No video games, Marvel, and anime sacrilege. Well, his argument is that atheists watch that stuff because we like to pretend or something. It's really weird. It's like he seems to think that because we like to play video games and like to do things that are obviously not real, that we, for some reason, that means that we know that our belief system is not real. It's really weird. It doesn't make any sense. It ignores the fact that escapism is a good way to, not have to deal with the real world. It's not like not permanently dealing with the real world. It's just escapism is a great way to not have to deal with all the issues of the real world. Because the real world can suck at times. So you play video games. Video games have a whole lot of interesting things. And NZPure says, I'm of the opinion that humans require narrative. If we add narrative to the world, this has my anthro bones tingling. Yeah. It's something that, I like a good narrative. you know, I've been reading, give me a few seconds. I've been reading a book, or a few books recently. Mostly because I still need to read the 7th book in the series, and I've forgotten half of the things that happened in the first all the first 6 books, except for like the most recent events. So I've been reading the I'm Number 4 series. Alright? I know it's fiction, despite the books telling me otherwise. Like, no. Yeah, despite the book literally saying the events in this book are real, names and places have been changed to protect the Lorien Six who remain in hiding. Other civilizations do exist, some of them seek to destroy you. Despite the book literally telling me that the book is real things, I know that it's fiction. You know, I know it's fiction. I am very aware of that. I don't have to... I don't think that everything that I read is absolute truth. Including this one. You know, people will disagree and say that this book is absolute truth, but I do consider it fiction. There may be a few stories in here that are based on somewhat real events, but that's any story will be somewhat based off real events, to an extent. You know, some stories are more based on real events than others. You know, it'd be like saying, what's a good example? Braveheart is based on real events. Yeah, that's more based on real events than something like I'm Number 4. However, it does have some historical inaccuracies. Right? That were put in there to make a good story. Yes, highly based on real events. But there are some issues with it. Right? Yeah, oh yeah, any Assassin's Creed game, right? It's very much based on real events, but there are quite a few differences. You know, I'm sure there's not an actual, Knights... I haven't played any of this, or I've played one of the Assassin's Creed games, and I've watched the Assassin's Creed movie. But yeah, that's my take on this. Yes, I'm going to be discussing Ken Wheeler. Alrighty, so... right, let's get back on topic, because that was a bit of a tangent. So yeah, in my most recent Ken Wheeler video, I asked 3 simple questions, right? And someone actually gave an answer, right? Music sound player. So, what was the first question? The first question was, okay, why does Ken Wheeler use counterspace and ether to describe the exact same thing? Right? Now, what he said, what Music Sound Player said, what they said, should I say, said there are 2 ether fields, magnetic and dielectric, right? So you got the magnetic ether field, apparently, and the dielectric ether field. Now, why not describe it as the magnetic ether field, right, and the dielectric ether field, rather than saying counterspace? And, like, the thing is, Ken Wheeler doesn't even define whether counterspace is the dielectric ether field or the magnetic ether field, right? I've never heard him define either of those things. Right? So, if you're going to if you're going, like, he literally said that the counter space can refer to like the ether or what? Like, he said that the ether, something inertial plane. You know, you when you're defining something, you should have specific words for specific things, and don't switch between words when describing the same thing. Be consistent. Use the same word to define the same thing. Sometimes we do have the same word to describe the same thing, but usually we try to be very clear about that, right? And usually there is some slight difference between things. I think you'd be hard pressed to find. Oh, a good example would be, yeah, usually there are differences. So, for example, let's take something like velocity and momentum. They're very similar things, right? But the difference between velocity and momentum is momentum is referring to the amount of, it's dependent on the amount of mass. An object with a velocity, the velocity is basically speed, right? Momentum is not just speed, but it's like speed based on mass. So if you have a higher mass but the same speed, so two objects can have the same speed but different momentums if they have different mass. Am I correct? Do people understand what I'm going with there? Like, you can have very similar things to describe the same thing, but generally they mean something different. I mean, we can use speed and velocity. Speed and velocity are the same thing. No one ever uses speed to refer to something in science. Now, people with less scientific minds will use speed, right? But people that are trying to communicate scientific things will use velocity. And I wonder if is there a difference between speed and velocity? Let me see. If there is, speed and velocity. Speed is the time rate at which an object is moving along this path, whilst velocity is the rate. Okay, so velocity and speed are slightly different as well. Okay. Yeah, Don Giovanni said, got it right. So velocity basically means that there's a vector component. Speed is the speed aspect. So velocity is the speed along a given direction. So you're heading, let's say, west. Speed is magnitude of velocity. Yeah, AB Science got it right. AB Science, you're free to join me because we are going to go over a Ken Wheeler video if you want. If I have time, should I say, because I want to go over this particular Ken Wheeler video. It's the plane of inertia and all sorts of life. Sounds fun. And AB Science got it right. So yeah, we've got different words to describe different things. Like, every instance that I can think of, there is different meaning to it, right? I'm hard pressed to find two things that literally mean the exact same thing. Number two, he said not an argument, and that's why I asked, why does Ken Wheeler define things, right, in relation to his own? So he comes up with a definition for something, but to understand any definitions he gives, you have to understand definitions of the other things, right? Now, I can understand that to an extent, right? But usually that's, it's a whole building up of knowledge. You start from a place of, there's usually a point that you start at, and then you go, okay, so this is the starting point, and you essentially, move out from there. Ken Wheeler doesn't really have a starting point, right? I have tried to find a starting point. The best is possibly his series on magnetism, but even then, you still need to understand all his definitions. I mean, RP says, "Hi, Plan and Walk. I'm here to argue the case for Ken." Ahoy, hoy. If you want to argue the case for Ken, join the stream debate thing. Essentially, join Discord. I've got a Discord link in the description, and then you can hop on. Just join the debate lobby, and I'll drag you in. Alright, so yeah, if you're going to define things. At least have a starting point. Don't order your definitions by in alphabetical order. Order your definitions in a way that you can start with one definition, and by understanding that definition, you can then move on to the second definition, understand that one, third, fourth, fifth. That's the way that I'd do it anyway. Yeah, sure, definitions in alphabetical order, simple and easy, but want to, order them in such a way that people can look at the first definition and go, okay, I understand that. Next definition. Okay, understand that. Next definition. Eventually, you'll get to definitions which may reference other definitions. But at least you've been to that definition and you understand that definition without having to know what this means. And I think Saroy is RP. And the third question that I had was, why doesn't he explain it in scientific terms? Oh, hoi hoi, Saroy. I'm assuming you're RP in chat?
Hello. Can you hear me?
Yep, I can hear you.
Yes, yeah.
Okay, I think what I'll start with is the three questions that I had. I think I'll start with that. If you want to get into, into those, or is there something that you wanted to discuss first?
These were the questions that were auto-generated.
No. Actually, I was talking about in the newer video, I had three questions that were legitimately... Yeah. So the first question that I had there is... I keep on forgetting it. Oh yeah, why does Ken Wheeler use the same... use multiple words for the same definition? To describe the exact same thing?
I suppose he uses the same words that Eric Dollard uses. At least that's my understanding. In that, just from my own point of view, just to explain where I'm coming from here, is that I'm not going to make any claims that what Ken Wheeler says is the future of physics, because he makes big claims. He basically claims that he's arguing or discovered the GUT, the Grand Unified Theory, and that all of existing physics is not true. So they're big claims for somebody to make. Yeah. I don't know if he's right. He could be right. I think his theories are very interesting. Whether they're accurate is a different question. But it's certainly interesting to explore them, and I do think they are coherent. So that's your question. He basically uses it because Eric Dollard, he was another kind of Tesla physics guy, I suppose is the best way to describe him, uses that particular term. And so Ken uses a couple of different terms that are basically synonyms of each other.
Okay. Might have to look into Eric Dollard and see what his whole deal is. Was that?
Yeah, so Eric Dollard is this interesting guy. He's probably about mid-60s now. Grew up in in near California, I think, in very near the old RCA studio in California. which I think is quite close. I think it's in north side of San Francisco. I'm trying to think of the name of it now. But he grew up as a kid, basically in the antenna fields of this old RCA. RCA is the Radio Corporation of America. It was an old government entity that basically took over all the radio patents back in the 20s, I think, originally. And it basically he grew up in one of their big installations, and he basically claims that he discovered a lot of or at least re-engineered a lot of Tesla's work from his time. So he's a very interesting guy who's got some very differing opinions about electrical engineering, and that he'd argue strongly that a lot of the existing paradigms that we currently use are all wrong again. Yeah. And so his approach is aligned with Ken. And if you've read Ken's work, he does make extensive mention of him.
Yeah, I think I might have heard Ken say one or two things about him, not a whole lot. I tend to hear Ken reference, Tesla a lot more, I suppose.
Yeah. Well, if you read his book, he's one of the people that he dedicates his book. He dedicates his book to is this guy called Eric Dollard, along with I think Tesla, Heaviside, and a couple of other people.
I suppose though one of the things that you brought up that I take issue with when it comes to people like Ken Wheeler, when it comes to people like Eric Dollard, is they claim to have this grand unified theory, right? Where they have, discard, like Ken, for example, discards gravity and says that it's all just magnetism. The issue that I have with that is with a lot of these things, they're basically throwing out a lot of things that have been confirmed. Computers wouldn't exist without things like quantum mechanics. I understand to an extent how transistors work, and I'm not sure that the theories that Ken Wheeler and potentially Eric Dollard use, I don't know much about Eric Dollard's theory, but I do know that Ken Wheeler would dismiss things like, when dismissing things like quantum mechanics, you throw out things like transistors, which were built using quantum mechanics.
Yeah, and this is why I'm not going to try and argue the case against, because strongly in favour of Ken or of Eric Dollard, in that if you can make these arguments that exactly the argument that you made, and which is quantum mechanics directly applicable to semiconductors? The argument that Ken will make is that it's not, but that's the mainstream argument. Like pretty much every physicist in the world believes that quantum mechanics is directly related to semiconductors. Now, I don't want to be in the position where I'm arguing against every physicist in the world necessarily, although I do think it's good to at least entertain the idea that they could all be wrong, but it's a big statement to make. I personally do believe in a lot of what Ken's arguments against quantum physics are, in particular like the things like virtual particles, which are really mathematical abstractions of an unknown process, effectively, that's convenient to fit into the equations. But that's the existing paradigm that we live in. Yeah. So although I agree with his criticisms of it, and I think his theory is very interesting, and it offers some interesting alternatives, it's a big statement to make, to throw it all out. So I'm not really in a position, I don't know is the answer, and I'm not really in a position to say that all of quantum mechanics is wrong. I think that he makes some strong arguments against it, but simultaneously he's also very much swimming up against the current of pretty much every established physicist or university in the world. So that's a big statement to make.
Yeah, because when it comes to these things, like let's take virtual particles, or even to an extent dark matter, right? Where there are certain unknowns, like we can't directly observe virtual particles, but if the maths basically checks out that these things should exist, or at least the maths works when we assume that these things exist.
Yeah, but the flip argument to that is that the maths don't work if they don't exist. So it's very much a it's very much a band-aid solution, in my opinion. Like, the maths work provided you put vertical particles in there, but if they don't exist, then the maths don't work. So, which is true? Who knows?
Yeah. Now, it would be interesting if we could come up with a way to observe virtual particles. And there are some experiments which, although we can't directly observe them, we can do experiments and we can say, okay, this is what these experiments predict if virtual particles are a thing, right?
Mm.
And these experiments work. So even though we can't say for 100% certainty that virtual particles are a thing, the maths does work. Like, a better example, I think, is dark matter. Dark matter, we barely know anything about it, right? That's why it's called dark matter. Now, the best, I think it's...
Well, dark matter is a very good example of exactly what I'm describing here, because dark matter is basically a missing part of an equation that they needed to plug. So that's where dark matter comes from. The sums don't work unless dark matter exists. So dark matter needs to exist in order for the equations to work. So it's very similar to a vertical particle, actually, but they're totally different conceptual things. Virtual particle is a quantum mechanical thing. Dark matter is more of a gravity like cosmology, astrophysics type thing, whereas quantum mechanics is very much a low level atomic problem. Yeah, but although they've actually very similar problems with them, or they're similar solutions to the same sort of problem, they're not really in any way related to each other.
Yeah, but like the thing that I'd say about, I'm just using it as an example because it's one that I have been looking into quite a bit recently because it's really interesting. Because I think one of the best ideas for dark matter is slow-moving neutrinos, which, because slow-moving neutrinos don't have a lot of energy, that would explain dark matter. But the issue is that it's very, very hard to detect slow-moving neutrinos because they don't have a lot of energy. We detect neutrinos currently because they're moving quite fast, which exerts a lot of energy when they do interact with the things that we have. Neutrinos are a good idea. However, if dark matter is made up of slow-moving neutrinos, then I don't know if it will be possible to ever get direct evidence that slow-moving neutrinos exist or are attributable to, or if dark matter is attributable to them. So,
yeah, it's an open question. I mean, that is proven. I mean, it's a theory currently. I guess I don't know an awful lot about neutrinos. I know that they have to detect them underground in some kind of caves, and they need to be totally isolated from everything. And I guess that, but I mean, I could be wrong about this, but I'm pretty certain that there's no conclusive evidence as such, or anybody's making the statement that dark matter and neutrinos are the same thing. Although, or at least in an experimentally verified way, possibly theoretically, people are making those arguments. But it's I don't know much about that, so I don't know.
Yeah, I was just giving an example, which, to wind back to virtual particles, we cannot detect virtual particles themselves. However, the maths checks out, and the experiments, whilst they don't confirm the existence of virtual particles, because someone mentioned the Casimir effect, right? The Casimir effect is explained by virtual particles. Now, there may be another reason for the Casimir effect, like with anything in science, really. There may be another reason, but virtual particles are the best explanation for what we observe.
Yeah, but virtual particles are used almost out for explaining almost everything in quantum mechanics. I mean, they're not just used for a couple of things. Magnetism is technically a result of virtual particles, along with they're basically an essential part of the whole of quantum mechanics. And very little exists without virtual particles.
Yeah,
So it's not just a couple of niche. It's not just like a couple of niche things that they're used to explain.
Well, that's why I bring up the Casimir effect, because the Casimir effect is not a direct observation of virtual particles, and when we're getting down to that level, it's very hard to have, direct observations. But they are an effect that is explained by virtual particles, and that's usually when we have these ideas in physics. It's usually, okay, what something would expect to see if we're correct. And if we are correct, we should expect to see this thing. If we're incorrect, then we should expect to see something totally different. And that's essentially what all of physics is about. If we're correct, we expect to see this thing. We see this thing, so we're most likely correct, but we may be incorrect.
And that's true in theory, at least, but often it's the opposite, right? This is slightly unexplainable, or using our existing theories, so we'll throw in a virtual particle to explain it. I mean, that's a controversial statement, but that isn't a million miles away from the way things actually work.
Well, not necessarily. So, for example, there's been a whole thing recently with, I think it's measurements of, I can't remember, I think it's either the strong nuclear force or the weak nuclear force, where they're off by a certain amount. I can't remember the rate that they're off by, but we're wondering at this point, okay, is this a new force? Can this amount that we're off be attributable to a fifth fundamental force? And the question is the question really is, do we need a fifth force, or is there something that we've gotten wrong? Is there something that there's all kinds of questions that we've got, and so it's really yes, a fifth force would patch up that small hole. However, it's a question of the muon G2, I think it is. The question is, okay, is there something that this, if we were to add a fifth force in, what would this fifth force look like? There's a whole lot of things that are unexplained right there, that just plugging in a fifth force wouldn't necessarily solve the problem.
Yeah, well, I mean, that's all true. You just have to, I guess the scientific method is such as you plug the hole, and then you say, okay, now that we've plugged the hole with this particular solution, if this does exist, what other experiments would show a similar effect from the same thing, So you have to, I mean, that would be the best way of doing it. And then if you could show that the assumption that this exists, then you can say that something else will happen that would result from this thing existing, and then do an experiment like that. That would be the way to go.
Yeah, because I think that what a lot of people don't realize is that, yes, you can plug the hole. Yeah, you can, say, okay, well, there's a fifth force, and I'm sorry to circle back to dark matter again. We can say, yep, there's dark matter, we've done it, solved the problem. But the problem with dark matter is that confirming its existence is a whole nother step, right? Yes, we've plugged the hole there, but we haven't confirmed that we've plugged the hole, if you know what I mean.
Yeah, exactly. So that's what they're trying to do now. That's what this neutrino stuff is all about. So they plugged the hole, and now they need to try and see if they're correct or not. And I suppose there's an assumption of some sort that neutrinos might be the solution, might be a way of observing dark matter independently of the mathematical solution that they've come up with. So that's what they're basically doing. That, I mean, that's what a lot of science is, I guess, is that you have a hypothesis, and then you have to try and test it to see if that actually holds water or not. So that would be, in my opinion, they haven't yet completely conclusively done that. I mean, but again, I certainly haven't seen anything that says that they can say that this is dark matter. They can't point and say it's something at the moment and say 100% that this is dark matter, basically. Yeah, I guess neutrinos is a possibility of something that they can then say it's dark matter, but they're not quite there yet.
Yeah, it is a possibility that, and I do like the neutrino idea because it makes a lot of sense. However, I cannot say, yes, dark matter is definitely neutrinos, because it's not something that has been experimentally verified, which means that it's still up in the air as to whether that is the case. And it could be that something like MOND, which stands for Modified I think it's Modified Newtonian Dynamics or something like that. It's a alternative to Einstein's theory of relativity. I can't remember if it's Modified Newtonian Dynamics or if there's another word in there for O. But anyway, with MOND, it's something where it's like, okay, this is another possibility, but again, that would be something that would have to experimentally verify, and with MOND, it's trying to explain the discrepancies that we see without the need for dark matter. Now, dark matter has its own things that it's... So, for dark matter explains things a bit better than MOND from what I've seen. So, for example, it explains things with why there's more matter or more dark matter apparently in some galaxies than others, which is most easily explained by dark matter. And MOND is something that tries to say, okay, well, what if we just don't use relativity, instead we use MOND? And that's...
Yeah, and I think it is important to say that there are some people out there that don't like the Roger Penrose comes to mind as somebody that doesn't necessarily agree with the mainstream arguments for quantum mechanics. He thinks they are operating on very flimsy ground. So it's not something that is 100. I mean, nothing in science and theory should be 100% confirmed. And you do have some pretty big name scientists that would say, he's the one that comes to mind. That would say that they don't believe that this problem has been fully solved, and there might potentially be issues with the underlying theory. So it's, and again, I haven't heard of this particular one that you just mentioned there, but it's good to hear that there are people still trying kind of left field approaches to try and solve some of the unknowns, the current unknowns that are kind of plaguing mainstream physics.
Yeah, and that's something that alternative ideas are welcome. A lot of people don't realize that alternative ideas are welcome. That's why we end up with things like MOND. The issue that I get with when we come to people like Ken Wheeler and potentially Eric Dollard is that they are saying, they're throwing shade at, quantum mechanics and all that, and also proposing their own ideas, but their own ideas don't... Firstly, I have not seen any experimental evidence for Ken Wheeler's ideas, right? And you have a lot of people that think that they're right, even though there's no way to even... I don't think that there's even any way to falsify Ken Wheeler's ideas, because there's nothing substantive there to falsify.
Well, I would disagree with that in the sense that I actually think Ken has got quite good experimental evidence behind some of his work, or at least he's got, maybe evidence is too strong a word, but he's got good explanations for phenomenon that he sees under things like the ferrocell or in other areas. That he's got it's a coherent theory is basically how I would describe it, in that there is physical evidence, or at least physical phenomenon, that he then explains using a coherent theory. Whether that theory is right or wrong is a different matter. I'm not going to make a claim on that, as I said, either way. But I do think there is a coherent theory behind. I mean, the obvious example, and the one he uses most, is the ferrocell and what you see underneath the ferrocell. And he's got a pretty interesting explanation for that doesn't really exist outside of his theory.
I think, and I may be wrong here. Actually, no. Let's trying to find decent tab to use to search something up in. This is a good one. Okay, alright, so I think AB Science had a video explaining the Ferrocell.
Yeah, that's also. I think I briefly saw that video. I didn't watch it in depth. And it was he probably has a coherent explanation for what's happening underneath the science cell, but that's not, or the ferrocell. But that's not to say that Ken doesn't also have a coherent explanation. It's just they're just two different explanations.
I think the other thing is that if you don't know, if you don't know the explanation for what's going, or the explanation that people normally give for what goes on under a ferrocell, then it becomes easy to say, well, there's no explanation outside of Ken's, or there's no good explanation, should I say, outside of Ken's thing. But I'd say that there probably is, but you may not necessarily have heard of it. And I'd love to get AB Science on here because I think he would probably be able to explain.
Yeah, no, but the argument you were making initially was that Ken has no experimental evidence for his for his theories, and the argument that I'm making is that yes, he does have experimental evidence that differs from the mainstream or from what AB Science, for instance, put together, but that doesn't necessarily mean that it's not a coherent theory, even though totally different from existing theories. So I'm not making the claim that his theory is necessarily right. I'm making that it's coherent.
I disagree because you find this all the time in flat Earth things where they have what appears to be, they have an explanation for something, right? Let's say explanation for why things disappear bottom up. They say it's because of the angle of attack. However, when it comes to things disappearing bottom up on a globe, we expect that because of the curve of the Earth. There are two different things there to describe the same thing. The problem that flat earthers run into, and the reason why I wouldn't say that flat earth is a coherent theory on that, is because it's essentially trying to predict the same thing, so there's no distinct difference there. It'd be like me saying, okay, yeah, objects disappear bottom first because of the angle of attack. We see objects disappear bottom first because of the angle of attack, so therefore the Earth is flat. That's an incorrect statement to make, because there's an explanation for the globe that essentially predicts the same thing. However, there's other things that come under that flat Earth doesn't predict that the globe does. And so just taking that one example where, yes, there's probably an explanation, if Ken Wheeler probably explains it to a decent extent, however, mainstream physics probably has an explanation that may even be better than Ken Wheeler's explanation, that doesn't come with all the other weight that Ken Wheeler's explanation comes with. I'd
argue that the flat Earth theory as such is coherent in the way that millions of people believed that for centuries. It's like it wasn't complete word salad or nonsense, which is the argument that you're making for Ken. It just happens not to be true, but it's not. That's not to say it isn't coherent. It's like the flat. I don't know really if the Greeks did. I don't think the Greeks really believed the Earth was flat, to be frank. But I guess some people did way back when. They decided the Earth was flat and they believed that, and that informed their entire worldview. So it wasn't. I mean, it might have been wrong, but it wasn't incoherent. It wasn't just nonsense.
I'd say that what I'd consider to be experimental evidence for Ken's thing for Ken's ideas would be something that there is no either no explanation for, or something where there is a substantial difference in what you'd expect to see, right?
Yeah. Go on.
I was just going to say, where there's a substantial difference in what you'd expect to see between Ken Wheeler's ideas and between mainstream, or we'll say quote-unquote mainstream ideas. Because
there is that video that he had. I think it's one of his most popular videos where he just, I can't remember exactly the experiment that he defines, but he claims to have a theoretical explanation for a particular what for some kind of physical experiment. I'm just trying to think what it is. Yeah, it's his most popular video, the Cook's radiometer video. I'm not again. So his theory, he claims, gives an explanation for the Cook's radiometer. So whether that's, I haven't watched that video in a long time, so I don't know exactly what he's saying in that video. But that is the answer to your question there. So he claims that he has an evidence of describing a particular experimental effect that his theory explains, but other theories don't. So
I'd say that I'd ask the question of, is there really no other explanations? And that's why I don't know if AB Science is still in chat. I think he's probably gone to bed. But because I'd probably want to get a scientist who might be able to explain this thing, right? And say, okay, well, is there an explanation for this? And how does it differ from Ken Wheeler's explanation? Because who was it? Glenn Solch in chat says, yes, they are the same observation with different attribution. Having two explanations for something, different attribution, no difference between what you'd expect to see, isn't really a thing. I'd want to see what does the science really say about it, and then we can take a look at that video right now if you want, though.
Yeah, let's look at the video. Actually, just give me 2 minutes. I'll come back.
Yeah. Let me go to Ken Wheeler. Oh, bugger. Do I get the same? No, I don't get the same recommendations. Damn. I had a video recommended to me, which I was thinking, I could. Anyway, here we go. Video sort by most popular.
Ball.
Oh.
Listen to me, God damn it! If you do anything at all, watch the video I sent.
Trace D says, okay, I will. I'll watch that later on today. It says, Professor no cheese hence 1 + 1 = 1. Oh, obviously it's in reference to a video that I made a while back. I think I might have briefly seen a comment that you left, I think, fairly recently. Let's see. Let me just... Oh, no. Unless I got your name. No, I didn't get your name right. Wrong. Yeah. Okay. I'm not seeing the... I'm not seeing... Hold on, I'll bring it up on the... No, I don't want to... I will watch that video though, because I've actually had people say that I was slightly incorrect, because Boolean logic is a thing where 1 + 1 = 1. So, and I mean, yeah, because like when it comes to programming, for example. A lot of languages you can check to see if something is true by, checking an integer. If the integer is greater than 0, it is true. If it's 0, then it's false. When someone says 1 + 1, they mean one object plus another object, not the concentration, temperature, and generally. Like if I have I have some glasses somewhere. Here we go. I actually had issues with this pair of glasses recently. But if I have a pair of glasses, another pair of glasses, I have 2 pairs of glasses. So I've actually got 3 pairs of glasses because I have more than, if someone were to give me another pair of glasses, I'd have, I'm holding this. Okay, I'm holding 1 pair of glasses. I add 1 pair of glasses to the amount I'm holding. I'm holding 2. We can add two things together, right? Oh, and I remember the comment now. Comment was on that video where it says if I'm holding a coffee or something, and someone gives me another coffee, and I can put them together, then they gave me if they're being that stingy that I can put both of them together, you only gave me half a coffee. 1 apple plus 1 pear equals 2 kinds of fruit, but it's still 1 apple and 1 pear. Yeah. But I haven't seen the video yet. I will get round to it. Praise Steve. I'll make sure that I get round to it before the end of the stream. I still can't. I in something. This is Crooks. Oh, this is the Crooks radio monitor. Whilst I'm waiting for a person to get back.
I'm back.
Okay. I was actually just going to say something that I've noticed about Ken Wheeler, because Ken Wheeler, he used to be rather skinny. And like when you go right back, he used to be really skinny, and it's like, certainly put on a bit of weight. Or, well, when I say skinny compared to how he is now. And I'm not going to shame him for that. Like, it's up to you whether you put on weight or not. It's just something that I've noticed. And seeing as he owns a farm, I'd actually expect him to, be in a bit better shape than he is. But again, each their own. Maybe it's not a farm that he does a whole lot of outdoor work in. And I think I've seen people that work on farms that are still overweight a bit. But, again, I'm not shaming. I don't think I've ever shamed him for being overweight, and I'm not going to shame him for that. It's just something that I've noticed. And, because, hey, who knows, maybe one day I'll be overweight and people will be like, you used to be skinny. And yeah, I am quite skinny right now. I actually should probably start doing some more exercise. I suppose that comment is more for people that have pointed out how he's really... And we've got someone in chat that is... Control-C. I'd use it on this channel. Where do we... Here we go. Settings. Yeah, it's for people that have sort of pointed that out. And it's like... Yeah, but he used to be, quite skinny, though. Okay. So, seeing as you're here, or I think you're here, we'll start... Or what I'll do is I'll actually share my screen so that you can see what's going on here, and we'll take a look at this. I'll try my best to offer an alternative explanation to what Ken Wheeler offers, but I cannot promise that I can. I'm not a physicist. I've just got to make that really clear. I tried to understand physics to the best I can, but sometimes, sometimes there are niche things that you don't quite understand. So, here we have Ken Wheeler claiming to solve a 140-year-old mystery. You ready for this? Saroy?
Yeah, sorry. Yeah, I'm here. And I'm not going to make any arguments that Ken is good at explaining stuff, or his videos are particularly well put together, by the way, because they're generally an absolute disaster.
Oh yeah, I will agree with that. Like, even if he was correct, like, when I try to put together a response video, quite often I'm okay. What's the central? Like, he will just ramble on for so long, and it's like, okay, I'm going to cut it off here, even though he's still speaking. Yeah.
It's 80% unnecessary words, and he never gets to the point in a reasonable time, and yeah, he's just a very difficult person to watch. But yeah.
Yeah. All right, we'll hit play and.
Okay.
Oh, I actually just realised that I need to do something. That should be a bit better.
I'm going to show you something that you've never seen before. This is a Crookes radiometer. You've seen that before. Obviously, it's been around for ages. But let me show you something first, and then let me explain to you something really important that I guarantee you do not know. Now, I'm just using high capacitance purple, i.e. blue in spectrum light, to sprint up the Crookes radiometer. This is a very low intensity LED, not touching the radiometer. You see it spinning up? Now, let's take a look at blue in spectrum. This is blue in spectrum, the purple was, but this is a less intense light source. Nothing. What about green or red? You'll get absolutely nothing. Nothing whatsoever. Just as bright, all same intensity. Apply purple light. Starts to spin up again. Not very fast, but this is a low intensity LED, but it's very high capacitance. The red LED with same intensity will never spin it up, nor will the blue. I'm about to tell you something really important here. Let me turn all the lights on, and let me come right back. Let me tell you what's going on, okay?
Okay, I'm just going to take a wild stab. There could be something, and this may be the explanation that Ken Wheeler gives. Whilst it seems really weird that, light would be able to speed it up like that, but I do know that light does have energy. It could be that the energy from the blue light is because that's higher energy than red light and stuff like that. However, I don't think it's substantially higher, and even if it's the energy, could be something to do with how I think it's microwaves do something. Yeah,
it's okay when his explanation is going to be the mainstream explanation for that is that they have different wavelengths, but the energy shouldn't really be different unless the intensity is different. And the argument he's making there is that although the intensity is the same in terms of the lumen output of the light, I guess, whatever way of measuring the light, it has a different effect. Even though, I know what his explanation for that is, but the mainstream, the problem is that the mainstream explanation for that would be if the intensity is the same, but the wavelength is slightly different. So blue light is about 450 nanometers, and the red light is probably about 633 or 650 or something nanometers. But will that 200 nanometer difference in wavelength have what effect? Why is that making a difference if the intensity is the same? Assuming that the intensity measured as a lumen intensity.
There's two possible explanations for that. The first explanation is that bluer light has a higher energy than red light. So the bluer light, the higher the energy. The redder the light, the lower the energy.
Yeah, so that would be like say you've two buttons on your torch or whatever. One button's low intensity and one button's high intensity, but the light is the same wavelength of light, same color of light. It's just the amount of battery that's being used to produce it, the brightness. So is that what you're saying, that the brightness between the red and the blue is different?
No, I mean the energy.
What?
So the energy. So I'm just trying to work out.
So if you think about this in like traditional physics, here we talk about photons hitting the radiometer. How many photons are hitting it per second or whatever? So assuming that they're both the same number of photons, it's just the wavelength is different. Why would that have an impact?
Because shorter wavelengths have higher amounts of energy. That's why the shorter the wavelength, eventually you get into the ultraviolet spectrum. Ultraviolet is what's known as ionizing radiation because it has higher energy. It can then ionize things. And when you get down to infrared, that has a lot less energy, so it can't. Even I don't think things on the visible spectrum can ionize. I think that's non-ionizing radiation.
Yeah, I mean, I would look at that in terms of photons. Like, there's a certain number of photons hitting the receiver, photons of light, I guess. And that would be defined when you say energy, I would think of it more of the intensity of the light. The amount of energy that the receiver is receiving from the light would depend on the number of photons that are hitting it.
But when you've got...
Not necessarily the wavelength.
I'd say that, even though there might be more photons, or might be the same amount of photons, if the photons themselves carry different amounts of energy, then that's going to obviously have a different impact. Again, that's why we have radiation that is ionizing, like ultraviolet, and radiation that is non-ionizing, like visible spectrum, all that kind of stuff. And it might also have to do with the fact that sometimes you get certain resonance. Like, I can't remember the exact thing. I'm gonna say resonance frequencies. Now, this is something that my explanation may be very shaky on, so I may be wildly incorrect on this. So if anyone wants to correct me, go ahead. So, this, I think, like resonance, some frequencies resonate with certain materials. I believe microwave frequencies, the ones that are in your microwave, they resonate with water, and that causes water to flip around, creating kinetic energy, which heats your food up in a microwave. I may be incorrect on that, but that could possibly be another explanation for this. I'm not sure which explanation it would be. I'd have to look into this, probably ask a scientist what's going on here. However, those are a couple potential explanations. The one says, has a good explanation of what I said earlier. You can get hit by 3 cars at 5 miles an hour, or by 5 cars at 50 miles per hour, both times 5 cars, but with different impact. I'd actually say it's more like getting hit by, if you get hit by a car, right, that's both cars traveling 5 miles an hour, right? You get hit by the first one, it's traveling 5 miles an hour, you walk away relatively unscathed. You get hit by a second car traveling at 5 miles an hour. Right. Actually, maybe it's... Actually, no. 2 cars going 5 miles an hour into a building. Better. Let's say 10 miles an hour. The first one crashes into the building. The building stays up. The second one crashes into the building. Building tumbles down. You replicate the building. You drive the second one in first. It tumbles down. Right. Both of those cars, they're both going the same speed or same velocity. However, the difference might be the mass, right? So you might have the same amount. I think that's a good allegory.
Yeah, so I've just had a quick look on Wikipedia there to see what the official theory is, because I don't know what the official theory is here. So it says the currently accepted theory was formulated by Osborne and Reynolds, who theorized that thermal transpiration was the cause of the motion. Reynolds found that if a porous plate kept hotter on one side than the other, the interaction between gas molecules in the plates are such that gas would flow from the hotter to the cooler side. So it's a pressure or a temperature differentiation is what he's claiming. So basically one side is heated up by the light and the other side doesn't receive the light energy. That results in a temperature differential between one side and the other side, and as a result, there's gas molecules move from the hot side towards the cold side whenever the pressure ratio is less than the square root of the absolute temperature ratio. That's the official theory.
It makes a bit of sense. I think that could be tested.
The problem with that is that, I suppose what Ken's saying there is that does red light heat up the side of it more than the blue light does? I suppose because the argument with that would be, so the red light would have to have a different temperature heating effect than the blue light.
Yeah, which is
at the same intensity.
Which is definitely possible. Hold on, let me see.
Yeah.
You said it was on Wikipedia, right?
Yeah, I'm just looking at Crookes radiometer on Wikipedia. That's the page I'm on.
Wikipedia. Radiometer. Because that seems like, that means that I was wrong. You see, as I said, I'm not a physicist. I don't know a lot about this. I was just making a few guesses.
But it's in a vacuum tube, so I don't know how many molecules there are in a vacuum tube. I have a couple of issues with that explanation, but I'm not saying, like, the argument there is that there's...
Well, it says containing a partial vacuum.
Oh, it's a partial vacuum, okay.
Yeah.
Yeah.
Okay, so it says here, the reason for the rotation was a cause of much scientific debate in the 10 years following the invention of the device, but in 1879, the currently accepted explanation for the rotation was published. Today, the device is mainly used as, in physics education, as a demonstration of a heat engine run by light energy. Okay, the radiant energy source directed at Crookes radiometer, the radiometer becomes a heat engine. The operation of the engine is based on difference in temperature that is converted to mechanical output. In this case, the black side of the vane becomes hotter than the other side as radiant energy from a light source warms the black side by black body absorption faster than the silver or white side. The internal air molecules are heated up when they touch the black side of the vane. The warmer side of the vane is subjected to a force which moves forward. The internal temperature rises as the black veins impart heat to the air molecules, but the molecules are cooled again when they touch the bulb's glass surface, which is at ambient temperature. This heat loss through the glass keeps the bulb's internal bulb temperature steady, with the result that the two sides of the vein develop a different temperature difference. The white or silver side of the veins are slightly warmer than the internal air temperature, but cooler than the black side, as some heat conducts through the vein to the black side. Two sides of the vein must be through. Okay. So, I'm wondering. I'm wondering if when you do, I think it's there are a few things that we could, a few experiments that you could do.
Yeah, well, just okay. There's this heating effect here. It would depend on, to a certain extent, on what material the actual the fans of that radiometer are made from. Do they absorb? Like a plant will absorb every light except green light, basically. You know, it depends on the. So, in order for this theory to be correct, basically, we'd have to say that the whatever those fans are made of in the radiometer, they'd have to absorb more red light than blue light, and that would have a heating effect because they'd absorb the light and heat up as a result. It's like, you know, if you put something black in the sun, it gets hotter than something white. So the argument here would be that particular material absorbs the red more than the blue in order for this heating effect to work, in my opinion.
Yeah, well, it seems like it's... So, with Ken Wheeler's explanation, or with what Ken Wheeler did there, it seemed like it absorbed blue light better than the red light. Now, I wonder what the effect would be with infrared light, because I think infrared light has a lot more heat than... Yeah, and Dan Hetfield made had a good question. What color are the radiometer blades? And that is a good question.
They're kind of a white.
Well, they'd be black, wouldn't they? At least the...
Well, looking at it there, they look white, but I can't really see it. Let me have a look.
Well, let me
the video.
See.
All same intensity.
They look kind of dark, because there's two sides of the radiometer blades, remember? There's the silver side. Because if we shine... I am really wondering if we can shine infrared radiation at it and see if it spins faster, because I think infrared has...
Well, that it might do, but it's kind of like that's not the argument that Ken is making here. He's not saying that he's just saying that in this particular case, what's the reason that the red and the blue light have different effects?
He zooms in at some point. Okay.
That's like a totally different question to what he's shown here. And the reason I can give you his reason is that maybe we won't go into what his reason is. It'll just confuse things.
Well,
his argument is such is that the smaller the wavelength, the higher the energy, and exactly what you were saying earlier, and then the longer the wavelength, the less energy. So in this case, the red light has got would have less energy in it than the blue light because it's got a longer wavelength. But that isn't really the official physics explanation as such for this. So that's Ken's explanation.
Yeah, and that might be part of the explanation as well, because
it's not the official explanation, which is the molecular heating effect.
Yeah, well, the thing is, the reason why I say that might be part of the explanation is there might be certain elements of the explanation that, different energies might cause different heating, right? And the thing is, that doesn't necessarily contradict what science says about light, right? In fact, science literally says that the shorter the wavelength, the higher the amount of energy the more energy the light has, right? That's why you have.
No, I don't think it. Like, the energy in science, at least mainstream physics, would be photon. Each photon has a particular amount of energy, which is, as far as I'm like, it's. I have to look at the energy for it, how you describe it, the energy in a photon. Let's just look that up. What exactly is a photon, and what's the equation to describe the so the way
energy of a photon calculator. Oh yeah, here we go. E equals HF.
Yeah.
So that's. You have higher frequency, you have higher energy, so H is Planck's constant and F is the wave frequency. So yeah.
Yeah, so okay. So it's the higher the frequency, the higher the energy of the photon. Yeah.
Yeah, so his explanation here doesn't seem to be different. And this maybe I have to give Ken some props here for having something that, I would agree with, because I don't often agree with him. Now, how he arrives at that explanation may be different, but, Colour does have temperature, but I'm pretty sure it's represented for colour. It's not natural thermal temperature. I know that when it comes to... Now, I'm not sure whether hot objects emit more infrared radiation or whether infrared radiation has a higher temperature. I'm really not sure about that. But yeah.
But what's interesting with this is that what's the reason that they don't just take that as I suppose from the Cook's radiometer point of view is that it shouldn't move at all, maybe. Like, there just shouldn't be enough momentum in light to have this effect, basically. So they're trying to, like, regardless of it movement or not, why is it moving in the first place? Maybe is the thing that they're trying to that they're trying to determine here.
Well, it doesn't seem that light it's not light itself that moves it. It seems to be the light heating it up that moves it.
Yeah.
And
but if that's... But then it should depend on the material, as we're saying, because it's like the black and the white material. If you put a black thing out, it's going to absorb more light than a white. Like, it then depends on... So you could, with the right material that absorbs red light very well, you could probably heat it up more than the blue light. But it'd be very dependent on the material.
Okay,
so Cook's... Yeah.
I was just going to point something that MC said in chat. For all material, when the frequency increase, more electrons are released. So so it seems that we've got a few explanations here as to what's happening, right? So it seems that the Cook's radiometer, should I say, when it's hit by light, that it creates thermal energy, which then causes things to happen. Very oversimplified explanation. Causes things to happen, which moves it. The light hitting it, the higher the frequency of the light that hits it, the more energy that it has, which releases more electrons, which raises the temperature more than... Didn't Planet already read off the explanation of the original experiment about a minute ago? Yeah, I'm also explaining why there's differences, why there could be differences in the...
So it seems that you're very much along the line of the original theory. So Crookes incorrectly suggested that the force was due to the pressure of light.
Yes.
So this explanation, yeah. Yeah. So if light pressure were the cause of the rotation, then the better the vacuum in the bulb, the less air resistance to movement, and the faster the vane should spin. So this is kind of like a disproved theory that that the because that makes sense. There should be less resistance to motion so I guess the theory that the light is pushing it around due to its energy has been disproven, or at least it doesn't fit with the facts.
Yeah.
Which is, I guess, why they came across this molecular heating effect.
Yeah. And that's why, I think that's why you have to do a lot of experimentation. What do these theories predict differently? And then you go, okay, well, this theory predicts that, if the light's hitting it, that moves it, then that theory should predict that the more light that, or this should predict that the better the vacuum, the faster it should move. However, that was disproven, so it had to be a different explanation. So that theory was thrown out. We've got... AB Science said, going to bed shortly, up early, starting new job. So that's interesting.
I'll be back in 2 minutes. I have to go.
And I just saw Wacky Tacky Joel's comment saying, "Is that Jordan B. Petersen's bedroom?" Yes. Yeah, and Q says the vane does not move in a vacuum, so I actually... yeah, I think... Yeah, this is Jordan Peterson's... Actually, he's cleaned it up a bit. Maybe. There's still a lot of junk there, but... he has cleaned it up a fair amount. Since...
I need to find...
Ads. There we go. We go to 7 months ago. Getsy, it's just getting worse the further back you go. This is Jordan Peterson's bedroom. Wait, hold on. Did Ken change his chair recently? Did he change his chair or... Oh no, it's just... Yeah, he's... His chair hasn't changed. I was gonna say, like, if he changes his chair, send that... I need a new chair! Yeah, I need... I'm guessing he's the kind of guy that could light himself on fire with the fire on that Mac stream. Maybe. And I'm actually very curious because I'm wondering what... I'm gonna just check to see what Ken Wheeler's explanation is, because his explanation might be maybe somewhat correct, but not completely correct. So, let's see.
Something that you had no idea about. And right now, I'm going to take a dump on all the ideas that you thought that you understood about modern science. This device is so simple, you can mail order one from eBay, $5 or $6. It's basically just two things. It's not even vacuum sealed, although this one might be. On the end of this needle is a little glass vial, of which are attached little veins of metals, coated white on one side, black on the other. If I apply a real high intensity light, it'll start spinning up. This isn't that high intensity, but you can see what's going on. You're like, oh, okay, well, this is boring. Well, hold on, I'm getting to the good part, okay? We think we're so advanced with our quad-core processors. And look, I was #1 for 2 years running on Apple for answering tech support on the MacBook.
But, I mean, we do have high processors, which does make answering these questions a lot easier, you know? And you can do calculations using computers instead of having to do them by hand. It makes things a hell of a lot easier. I mean, that's how we've gotten like trillion digits of pi. Sorry, I'm just adding a bit of, you know, I like to retort to videos that I'm watching.
Okay, we think we're so advanced. Look at this. This is today. This is not, yesteryear. These are all the theories about how the Crookes radiometer works. There are many, many theories. You see, this simple thing, which is more simple than a damn saltine cracker, modern science. Oh, we've got particle accelerators in France, and we've got the Hubble telescope, and we're so advanced. No, we're not. Modern science has still not come to conclusion as to how the hell this works. Don't believe me? Don't give a damn. Go research it for yourself.
I mean, we do. I mean, we do have explanations, though. Like, Wikipedia does give 2 explanations. You've got the movement with black body absorption and movement with black body radiation. Actually, that would be the same sort of thing. The currently accepted theory was formulated by Osborne Reynolds, who theorized that thermal transpiration was the cause of motion. Reynolds found that if a porous plate is kept hotter on one side than the other, the interactions between gas molecules and the plates are such that gas will flow from. Yeah, that's basically the thermal, the movement with black body explanation. Brilliant. Yep, that's the exact same, pretty much the exact same explanation. So, it's due to air heating up, due to the plates heating up, and the plates heating up causes the air to move up, which causes the air to apply force, which moves the plates. Very simple. We understand this.
There are thermodynamic explanations, which, kind of seems logical that, if you turn it on the white, you can actually stop it, but if you point it towards the black, it starts to spin up and be like, well, it's heat. Black heats up faster, and therefore that's why it starts to spin in the direction of the applied light. There have been mechanical explanations, especially these particle idiots that think, well, it's actually light beating on the black veins and, pressing it pressing against a car or something. Thermodynamic explanation, black body radiations.
Okay, I got to laugh. Ken Wheeler doesn't understand what he's talking about. I take it back. Ken Wheeler is not correct. He doesn't understand what he is talking about. Jesus. I understand that the black body explanation is the thermodynamic explanation. I am sorry, but I have to. Any props that I gave to Ken Wheeler there, I'm sorry, I'm taking them back. The thing is, if it was actually light that was hitting it, if it was light that was hitting it and applying energy momentum to it, then that would mean that it would be, it would probably work on the white side or the silver side of the veins, because that would be energy would be reflected. And when you reflect, every action has an equal and opposite reaction. Although that would also mean that you'd be able to shine a light on your wall and or on a silver thing and move it. Like, imagine shining a light on a mirror and your mirror moving.
Force explanations, pressure explanations.
Okay, so the pressure explanation is incorrect, or the light pressure at least. The force explanations are pretty much the same, or probably the same as the... in fact, I think when we go to Wikipedia, there's a partially correct theory, and that's the gas molecules hitting this warmer side of the vein, right? And that's partially correct because, whilst it's not the full explanation, it is... And Ben Solch says he's right, you just don't understand how... He is not right, though. If he was... Well, he's not... He's gotten things incorrect already. He doesn't understand this shit.
I think he's just arguing that the existing ones aren't right. He hasn't really said his own theory yet. He's just saying that these are the various theories that you can read all the theories he's just mentioned on the Wikipedia page there. You got the light pressure theory, the thermodynamic pressure, thermodynamic black body stuff, the black body absorption. So I think he's just going through the different theories that currently exist.
But the thing is, if he understood these things, he would understand that the black body theory is the thermodynamic explanation. That's, and that the currently accepted theory is the same as the thermodynamic explanation. This is something that,
well, yeah, I mean, I don't actually disagree with you there, but you can. So the black body is more a specific type of thermodynamic explanation, I would say. There's two. If you look at the Wikipedia page, there's two different black body examples. There's black body absorption and black body radiation, but they both fit within thermodynamics.
Well, it says here when the radiometer. So I think the movement with black body radiation is not. So it says movement with black body absorption and movement with black body radiation. I think it's the same kind of explanation, right? Just two coins of how to make it move. It says here, when the radiometer is heated in the absence of a light source, it turns in the forward direction, i.e. black sides trailing. If a person's hands are placed around the glass with touching it, the veins will turn slowly or not at all, but if the glass is touched to warm it quickly, they will turn more noticeably. Which means that you can move it by heating up the glass.
Yeah, but they're quite different. Like, one you shine a light on it, and the other you heat it up. So they're quite different. One is emitting heat effectively because it's been heated up, and as a result it emits heat. The other absorbs the heat from the light source. So they're kind of two different. They're related, but not the same thing.
But they're both
they have two different explanations.
But they're both correct, right?
Well, they're both explanations. Yeah, I mean, I don't know if they're correct, obviously. But this is the current state-of-the-art accepted theory. I mean, if we went back 100 years, the incorrect theory would be the accepted theory. So, at the moment, this is the official theory.
The thing is, with these two explanations, it's doing two different things to heat it up. The absorption, right, is basically saying, well, if you heat up the glass, that will move it, as well as if you heat up the veins with light, right? These two things
the absorption one is saying that if you shine a light on the vein, it'll absorb heat from the light. The other one is saying if you heat up the vein, then the vein will emit that heat that you've heated.
The other one...
Well... It says that there, when the radiometer is heated in the absence of a light source.
Yes.
So,
If a so it says if a
then?
person's hands are placed around the glass without touching it, the veins will turn slowly or not at all. But if the glass is touched to warm it quickly, they'll turn more noticeably. Basically, this is saying that you can turn the veins in different ways. You can turn it by heating the glass, or you can, which will obviously heat up the air molecules in that, which will turn the turn the veins. But if you heat up by shining a light on it, it will also turn the veins. There's basically two different ways to turn the veins, and it's explained by the different explanations. But the overall explanation is a thermal explanation, and when you go to the currently accepted theory, it's also a thermal explanation, and it's the same explanation as the other explanations, or the other thermal explanations, should I say?
Yeah, the first paragraph, I agree. That the second paragraph says that the glass is cool quickly in the absence, so this is a cooling effect. Then it turns backwards. So that's the emission, not the heating.
That's the.
So one way it absorbs it, which is what you're saying, you either shine the light at it or you put your hands around it, it absorbs the heat or the light. But then if you cool it, it is already hot and now it cools down, and then when it's cooling, it still turns because it now is emitting light, or it's radiating the heat that it already has absorbed previously.
Well, it's radiating. Well, it's more the heat, transfers to the molecules. The molecules then push the vein. These two explanations are basically the same. They're a result of the same mechanics going on, basically. Does that make sense?
Well, one's absorption and one's emission, so they're not really.
But the same
one is absorbing energy and is having an effect from the sunlight. Like when we heat up in the sun, the alternative is when we cool down at night, we're emitting energy then. But they're not the same thing, really. I mean, they're possibly similar.
Well, it's a result. The same mechanism. The result of the thing turning is the explanation of the thing turning. Because of that explanation, there are two ways to move it, right? If it was something like light, there would only be one way to move it. And because, you can shine a light at it, and turns it, because, it absorbs energy from the light, turns that to thermal energy. That thermal energy gets transferred to the gas molecules, and then the gas molecules, that causes it to move, which pushes the veins. Whereas with when you heat up the glass, right, that also transfers energy to the gas molecules, which turn the veins.
Yeah.
Yep.
Yeah. So that's that the argument there would be that you're heating it up in different ways, and that's the heating effect that's causing the veins to turn.
Yes.
But that doesn't necessarily mean that when it cools down, it should also turn. That's.
Well, I'd have to take a. Hold on, let me. Glass is cooled quickly in the absence of a strong light by putting ice on the glass or freezing in the freezer. It turns backwards, i.e. silver sides trail. This demonstrates black body radiation from the black sides of the vein rather than black body absorption. The wheel turns backwards because the net exchange of heat between the black sides and the environment initially cools the black sides faster than the white sides upon reaching equilibrium. After a minute or two, the reverse rotation ceases. This contrasts with sunlight, which forward rotation can be maintained all day. Yeah, so it's basically saying that, when it comes to the mechanics, it's really just due to heat differences and the yeah. And I'll see what Ken Wheeler's explanation is, because I think that Ken Wheeler's explanation is going to be wrong. He may get some certain things correct, like he is correct if he does mention that the higher the frequency of it, higher the light frequency, the higher the energy. He is correct in that is a difference, but he might be incorrect about the explanation, and I think he might be incorrect about the explanation. But let's see.
This device has been around for a long time, this Crookes radiometer. Science has still not figured out how this works. I, however, have, and I'm the first person in the world who has. And the reason I have is because this...
Okay, I'm going to immediately, right, just point out, when someone says they're the first person in the world to figure out something, right, unless it is something like extremely personal, right, like, let's say that you're, like, it's, I'm the first person to figure out that my wife was cheating on me or something, right? Unless it's something like that, well, yeah, I can understand that. But if you're the first person to, you know, figure out something that a lot of people have looked into, especially, at least he's not saying that he's the only person that understands this. But he is saying that he's the first person, and he's making a YouTube video, he's not publishing a paper on it. You know, if he published a paper on it, then I'd be able to take him a bit more seriously. But, you know, I think that someone claims that, I think that they're probably, you know, trying to hype up their own ego.
Fat bald tattoo freak you see in front of you. You know, he was a genius, chess champion.
Hold on.
This fat bald tattoo freak you see in front of you. You know, he was a genius, chess champion.
Okay, maybe he's... Okay, I'm not going to make fat jokes about him, but maybe he is okay with it. I don't know. Like, he seems to be or at least self-conscious, or self-aware of that, should I say. But did he just say that? Oh, I want to have a game of chess against him. Oh, Ken, buddy. Let's have a game of chess. I might lose, but, you know, let's have a game of chess. I just want to have... Oh, that sounds like it would be fun. Now, I will agree that chess is not a... Like, being good at chess does not necessarily mean that you have high IQ or whatever, but I want to have a game of... Ken, if you're watching this, I want to have a game of chess against you. Let's make it happen.
In high school and college, translate ancient Greek for fun. I literally wrote the book on magnetism, and I'm the first person to accurately tell you what light is. It's a coaxial circuit. It's not merely transverse electrical and magnetic, but has a longitudinal dielectric. And Mother Nature, she's a really, really simple gal. Okay, she's not an insane hooker on crack, as quantum mechanics would have you believe. She only understands two co-principles, force and motion, and inertia and acceleration. The entire universe is resistance, capacitance, permeability, magnetism, permittivity, dielectricity.
I'd say that, you know, I'd have to dive into what he means by all those things, because, like,
Yeah.
force and acceleration are both basically the same kind of thing, right? The only difference between force and acceleration acceleration doesn't... I mean...
Yeah, well, as I said, I'm not going to defend Ken's video technique because he's just meandering there into all kinds of thickets.
Yeah.
I mean, there's not... he doesn't need to be saying all that. But he needs to get to the point quicker.
Yeah.
I agree.
Because my point here is that acceleration and force are basically this very similar things. Like, acceleration is caused by force, right?
Yeah.
Or force is...
Yeah. He'll say they're different. Officially, force is equal to mass times acceleration, so they're related depending on if you want the official definition of what a force is mass times acceleration. Now he will say that they're different, and he doesn't agree with any of those terms, and he doesn't agree that they are related.
Yeah.
So that's where he stands on it. But yeah. Yeah, in terms of what you're talking about, then they are the same.
Yeah,
or at least they're...
I'd say that, like the main difference, really, when you get down to it, is acceleration. If you have two objects accelerating, they can be two different masses, right? And they accelerate at the same rate. The acceleration may be the same, but the force would be different, and that's really the difference. The only difference you can have is that there's just different ways to describe the same thing, except taking into account different factors, really. Anyway, well,
yeah. So what he describes as acceleration is really gravity, basically. So he describes the force, and it's called a force of gravity, as acceleration. So that phenomenon known as gravity, we'll say, is acceleration.
Yeah, and
when he describes a force, it's more like the force that keeps your car moving at a constant speed. So it's not speeding up or slowing down. It's just a constant velocity force that maintains without changing its speed or velocity. It's the force that keeps your car going at the same. So it's a.
That's the force that keeps your car going at the same speed. That's two different forces that are acting upon that. That is the force of air resistance and the force that your car produces to be able to move it along in the first place. When you're slowing, that force, if you increase the force that your car is producing, then your car will accelerate, to get up to a higher speed. I can understand why he might call gravity an acceleration and not a force, because gravity does... officially, gravity is not a force, but that is because of when you're traveling through space and time, and you travel around an object where there is curved space and time, you're going to curve into that. You're effectively traveling in a straight line through space-time, but from our point of view on Earth, it looks as though they're curving towards the Earth. That's probably the best explanation that I can give.
Yeah, I mean, he relates the force to something called magnetism. So magnetism and force are the same thing in Ken Wheeler's world, where magnetism creates a movement. It's like a movement, and then the acceleration is a different, acceleration is then related to the dielectric, which is a contracting force. So one force is an expansion, and the other is a contracting. And the contracting one is what he calls the dielectric force, and the expanding one is what he calls the magnetic force. And then he links the acceleration to the dielectric, the contracting force, and the force/motion to the expanding force. He sees everything in terms of either an expansion or a contraction, and they have two different kind of attributes to them. One, the expanding force is related to magnetism. It's an expanding, like blowing up the balloon, and then the contracting force is more like when the balloon explodes and all the air rushes in. And they're just fundamentally different. And one he calls acceleration, and the other is force and motion.
Yeah, odd.
But that's a very, very different, a totally alien way of looking at things
to
anything in mainstream physics. So
yeah, it is something that I'd have, because some of those things, it's like, okay, I'm not going to really argue there. Like, for example, what I'm not going to do is I'm not going to say, hold on. Sorry, I just got distracted by Glenn Salt saying acoustic radiation, if you remember talking about sound being electromagnetic. Glenn, are you the person that said that sound is electromagnetic? Or was that someone out? I think it was you, actually. Hold on, I can search that up. Glenn. Oh, yeah, yep, it was you. Oh, jeez. I now remember. Anyway, what was I saying? Oh, yeah, Ken Wheeler like some of the things I won't necessarily argue against because it's like, okay, I don't really understand this well enough to argue against it, right? I think that's...
The interest in Ken Wheeler really, and I suppose why I get interested in what he has to say is that he just has such an alien way of looking at things to like any of the mainstream physics theories. So it's like entering a totally different world when you're dealing with Ken and Eric Dollard. And whether they're true or not is kind of irrelevant to the fact that it's a mind expanding experience to engage with the ideas and to see the kind of conclusions they lead to.
But the thing
because go on.
I was going to say, the thing with having an alien way of looking at things, some people having an alien way of looking at things can be interesting, like, but that doesn't, it, like, I suppose it would be something like, I've had ideas of, the whole, like, for example, I've had ideas of gravity being attributable to particles that just exist everywhere, and when an object is moving, through a place, it just pushes those particles out of the way, and when you collide with those particles, you're just pushed towards an object. Obviously, that explanation of gravity is incorrect. It's a different way of looking at the universe, and it was a way that made sense to me back in high school. I now know that explanation is incorrect, and that there are better explanations out there. I think that it's something where I prefer, like, if I'm going to take someone seriously, I want explanations that are going to be, correct, and I can't. And I want to leave with more answers than I have questions, really.
Yeah, that makes sense. I mean, Ken is almost impossible to decipher, by the way. Like, he's, as you said, he's so, his videos are so inconsistent. He goes off in tangents. He's, he goes on about how smart he is, and he's the first person to discover this XYZ. And like, he's not a good communicator, basically. He's a very poor communicator. But that's not to say that... Well, it's actually wrong to say he's a poor communicator, because he doesn't quite communicate quite well on his videos on photography gear or kind of other things. Like, he's very clear in what he's trying to describe. But when it comes to his magnetism stuff, he... it does make sense. That's the only reason I kind of came out here was to say it does make sense. If you're willing to put the work in to understand it, but whether it's accurate or not or true is a different story. But it's definitely an interesting explanation, and it's got some interesting ideas.
So Glenn Solch says, so F equals ma, but if acceleration is 0, then so is F. Yes, that is correct. If acceleration is 0, then the force is 0.
Yeah.
Like, for example, I was talking to AB Science about differentiation and integration, right? And I was trying to understand it. Some things made a little bit... Sometimes he would say something which made it make a little bit more sense, but I still didn't quite understand it. And I understand that it's more of a mathematical thing than like what Ken is talking about here. So it's something that, it's definitely me not understanding it. And that's why when it comes to Ken, like, I try to understand things, but I feel like with Ken, it really comes down to, like, a lot of the understanding that people have of him is down to personal interpretation.
Yeah, I think there's very few people that understand what he's talking about, frankly, because he's very hard to understand. He's extremely difficult. His way of looking at the world is totally different to like the way we've been taught. Completely different. And he's like, Ken is like a fundamentally metaphysical monist, like monist. He's a monist, which means he believes in it's it's a Vedantic. His philosophy, the way he looks at the world, is he follows like monistic philosophy, which is Vedantic or Neoplatonic philosophy, which is just totally alien to anybody that's currently really alive today, and it all follows from that. His explanations.
I do have to say something. Glenn Solch in chat said, so if F is 0, then there's no gravity acting upon an object at rest. No, there's essentially... What you can do is you can add a whole lot of forces together. When you are... So, for example, when you are traveling down the road, constant velocity, there's no acceleration there, right? But there's still forces acting upon you, right? You're not accelerating. You're not... you're just going as constant force. There are two opposing forces. So because the two forces are opposing, the net force, right, that's the total amount of force that's acting upon you, may result to 0, causing there to be no acceleration. I'd say that acceleration is more a result of forces rather than forces being a result of acceleration. That's just what I'd say, though.
Yeah, you're still under the impact of force when you're walking around. Like you still have gravity. It's just that the bed that you are on or whatever is preventing you from falling deep into the middle of the earth. But the force is still there.
Yeah. I'm going to continue what Ken Wheeler is saying, because I want to know if he's going to be wildly incorrect about this, or if he's going to ramble on for another 10 minutes about nothingness. We'll see. Probably a bit of both.
Okay, well, what about that? It means the explanation for this is 100% correct based upon everything that I know about magnetism, which is complete, and everything that I know about light, which is also complete. There's no such thing as a speed of light. It is a rate of induction. The maximum rate of transverse field phenomena through a medium. That medium, of course, being the ether. There's no such thing as warp space-time.
Okay, I'm going to just say that his sort of rate of induction thing here is somewhat correct. I can understand where he's coming from. So what he says is the rate of induction is basically there's a particular word for it in physics, but I can't remember it. So we'll say rate of induction. Essentially, so for example, gravitational waves through space-time, they actually travel at the speed of light. And the reason why they travel at the speed of light is because it's the fastest anything can really move, like any information can travel, right? So John Eagle says, sound like word salad, would I be correct? I would say that you are correct. Some other people might disagree.
Well, what he means by rate of induction is just the light acts like sound waves. So sound wave travels by pressure waves through the air, and it takes a while to propagate. Basically, what he means by rate of induction, he really just means propagation. So he means propagation through the air in the case of sound waves. Nothing is traveling with the sound waves, what he means. So when you speak, there's nothing physically going from your mouth to the person's ear. What's happening is there's a lot of pressure waves being set up in the molecules of the air all around you. And what he's saying there is that light is the same. It's a pressure wave going through the ether. It's nothing to do with particles. There's not a physical particle, is what he's arguing there with light. It's more or less identical to what happens to the sound wave when you speak.
Well, light is, there's the whole live wave particle duality, which is due to things acting like particles and waves in really weird ways.
His argument is that isn't true. That's what he's arguing there.
Yeah,
he's arguing that phenomenon isn't true, and what's actually happening is closer to a sound wave. So that's his argument.
But the thing that I'd say when it comes to the whole rate of induction, right, is the fastest anything can move is the speed of light. And like when let's say gravitational waves, right, they move at the speed of light. However, like it's just, in a way, that's just like perturbations in the space in space time, right? That's like So it's yes, he is correct in a way. So I will give him that. Like, it is something that it's more due to the rate of transfer of information. So when we say information, that can mean, like, if I turn on an electromagnet, right? It's nothing. If I have something that's a light second away from it, right? And let's say this is a really powerful magnet. I turn it on. That thing isn't going to. The thing that's a light second away from it isn't going to be affected until a second after I turn it on, because that the electromagnet isn't going to. The magnetic field that it produces isn't going to affect it until a second later.
Yeah, exactly. So it takes a period of time for it for that to occur.
Yeah,
which is basically what he's saying. Yeah. In the same way as the speed of sound, when I speak, you don't hear what I say instantly. It takes a period of time for it to go through the air to you.
John Eagle says, thought they were taking the piss. You'd think that you'd think that he is, but I think it's, when you go down to the comments, you can read this as, someone says, finally, someone who knows everything. Mankind has been searching you for you forever, my friend. That sounds like it's someone taking the piss. However, the fact that I hear so many people that act like he is correct about everything, here we go. We are intelligent but not very wise. We are advanced in certain areas but incredibly ignorant as to the mechanics of Mother Nature. Beautifully said. I can say for certainty that this comment here is not taking the piss. And yeah, here we go. Another one. Always interesting to learn different theories from different folk and the passion they have for science and nature. Thank you. I don't think Ken Wheeler is taking the piss. I think that he's someone that's just trying to come up with his own thing. Someone in the chat said, speed of light. Where is it? Light doesn't travel at a constant speed. Well, technically no, because when it travels through different mediums, right, the speed that it travels is affected by the oscillating of electrons within those mediums. Glenn says Ken Wheeler is not correct about everything. Oh yeah, I agree with you there. Right. I don't think that Ken Wheeler is correct about everything. I think that he's correct about very, very few things. And I will give him props where he is correct. I just think that the way that he arrives at some of the things that he's correct about may be incorrect. It's like reaching the correct, he's reaching the correct explanation, but taking the wrong way to get there, for example, if I say that there is no God, right, and my explanation is that I have not seen enough evidence for there to be a God, right, and then someone says that there is no God, but that's because, I don't know, the Christian God is stupid or whatever, then I'd say that we're both correct. Some people may disagree. I'd say that we're both correct, but we took different ways to get there, and one of them may be a better way to get to that position than the other. That's what I'd... I like John Eagle's thing saying, well, all I know is that the speed of light is slower at night time. That's a funny... Anywho, well, sounds like Soroy is back, so we'll see what Ken Wheeler has to say.
Einstein was incorrect on this. There is no premise to back this up. It's dielectric acceleration. That which we call gravity is dielectric acceleration. The same thing that you saw. See, science, by the way, has no idea. There's a famous quote from Tesla that goes, if you want to understand the universe, you need to think in terms of frequency and wavelength. And of course, correct on that. And people quote Tesla on that all the time, but they have no idea what the hell Tesla is saying. He's not simply saying frequency and wavelength. What he's talking about is capacitance.
I just have I don't like when people quote Tesla as though he's an authority. He was good. He was a good engineer, I think, but he wasn't a great physicist. You know, there's difference between being an engineer and a physicist. An engineer will understand certain things and may even be able to come up with interesting inventions. Being a physicist is an entirely different ballpark. It's, you know, you're trying to find... Being a physicist is you're trying to find things out about the universe. Being an engineer is you're trying to make things work in the universe. Similar fields, different... different things.
I mean, that's true to an extent, but is the best way of finding out how things work in the universe is often to experiment with the way things work on a practical level, not necessarily strictly theoretical level. I mean, physicists do experiments in theory, so that is that not?
Well, a physicist is more trying to find out what's happening on a fundamental level. An engineer, right, is trying to just make things work. The explanation for something could be incorrect, and that's why when they laid the, sometimes as an engineer, you will get things incorrect, things that don't work, and because you don't understand something correctly, and that's why when they laid the first cable, I think it's like transatlantic cable or something, because they're using iron to wrap the cables, they didn't understand that would cause issues with the cables that were being laid because, iron is ferromagnetic. When you are a physicist, you're trying to understand, okay, why does this work? And you can come up with explanations that will inform engineers be able to make better things. But as an engineer, you're just trying to make something that does work. You're not trying to understand why it works. You're just trying to make something that does work. That's the difference.
Yeah, but I mean, but Tesla's example of the exact opposite happening. Like, he invented it, and then the physicists came along later to try and explain it. It wasn't the physicists giving input to Tesla and then him inventing things based on their input. Well,
yeah, but that's still a difference. You may be able to make something that is, that physicists can't explain, but that doesn't mean that you have the explanation for why that works off the bat.
Yeah, but I agree with you, but it's the engineer in my mind is actually pushing forward the progress there, not the physicist. So if you look at who's making the actual progress in the Tesla versus physicist case I just gave, it was Tesla that was making the progress because he was coming up with these inventions
He may have made the progress, but that doesn't mean that his explanations for why everything worked were correct. As an engineer, your goal is not necessarily to explain why things work, because you're just trying to make things that do work.
No, I agree, but I'm just saying that if you found two people and said which is pushing forward human progress more, in my mind it's the experimenter or engineer more than the physicist, because there aren't that many cases of the physicist coming up with an interesting theory and then that theory straight away leading to a bonanza of progress. It's more likely an engineer will tinker or experiment with certain things, and you'll try things out and discover something, and then the physicist will later come along to try and explain that occurrence.
Not necessarily. Quite often it is just experimentation producing wacky and weird results, and it's like, okay, what caused this wacky and weird result, right? Sometimes there will be an engineer that comes along with something that produces a weird and wacky result, and physicists trying to explain this weird and wacky results. But it's more often than not, at least these days, it's because, let's take, what's it called? Fusion. That is nuclear fusion. That's something that is ultimately going to be pushed forward by physicists finding out ways, because, we've gotten all the simple stuff out of the way, and a lot of these things you do, these days that they're trying to make, you do have to have a decent understanding of physics. Way back when, obviously, physics wasn't as advanced as it is now, so there was a lot of things that you could get weird and wacky results from. And Glenn Solch, a Flamo, wondering who Wolfie 3010 is. I am Wolfie 3010 because Wolfie 6020, and this is coined by Mick Flatty, Wolfie 6020 is apparently my father, because we're both Australian, even though I'm Kiwi, but Australian and Kiwis are basically the same, so, and people can't tell the difference between our accents, so I'm clearly Wolfie 6020's son, because there's only 2 people that live in Australia and New Zealand. So that's just a thing. Anyway, I'm gonna push on with this video, see what if he eventually gets the explanation. Hopefully he does.
He's talking about the nature of that. You actually change, given a inertia or field perturbation. When you change the wavelength, when you change the frequency, you change the capacitance, you change the power. What happens when you think you go towards the red end of the spectrum out in the sun? Well, you're going to get a sunburn, not too bad. You start heading towards the blue end of the spectrum, whereas where all the dangerous crap is, X-rays, everything else, that's when it'll kill you in a heartbeat. There is more capacitance per dielectric pulse in the longitudinal coaxial nature of light than there is towards the red end of the spectrum, okay? I'll sit here all day long with a...
So essentially, he's kind of correct here, but he's like, this is the problem that I have with Ken Wheeler. He could explain things in such simpler terms, and that would, if he's explained things in simpler terms, like using terms like energy, right? Energy is a really good explanation for what he was going on about there, because, photons or light has higher energy when you raise the frequency. You don't need to go dielectric capacitance to explain energy. You just need to say energy.
Yeah, I mean, his theory is basically what's called the incorrect theory in the Wikipedia article, really. He's saying that, with the theory that is intuitively obvious, the theory that you originally picked up on when you were looking for an explanation, which is that the wavelength of the light has different energy contained within that wavelength, and that's what's causing the movement.
Yeah.
And so his theory is basically in alignment with what Crookes originally thought back in the day, in 1800 or whatever, when he originally invented this thing, which was that different lights have different abilities to push, so pressure, I guess.
Yeah.
But his explanation for why that exists is totally different to the mainstream physics explanations, which is why he uses those different terms. It's not that he could use other terms. He just has a fundamentally different view of the way things.
It's more. I think that it's better. It'd be better for him to use other terms, because when he uses the terms that he does use, because these terms aren't very well defined, it leaves a lot of ambiguity, and that's a lot of the issue that I have with Ken Wheeler, because he uses a lot of word salad, which word salad ultimately leaves a lot of ambiguity, and that's kind of the point. That's why I have disagreements with Deepak Chopra, with Jordan Petersen, who Ken Wheeler is obviously trying to emulate. Must be a connection between word salad and the amount of counter space you have.
But the thing is that he like every one of those terms that he just used there has a fairly precise definition to it.
I don't think so. I think that and our Flamio says, I'm willing to disagree with Wolfie 3010 with me. My mic works. I'll bring you in. We're gonna have 2 people disagreeing with me. How fun! last time this happened, it was a flat Earth debate. The issue that I have with... The main issue that I have with Ken Wheeler is that he doesn't use very precise terms. His terms are... When I've looked at his definitions, the terms that he uses are usually referential to other terms in his definitions, right? So, for counter space, it refers to the ether, and then that refers to another one of his terms, and eventually you ultimately end up in a loop where to understand one term you've got to understand this term, but to understand that term you'd have to understand that term, but to understand that term you have to understand that term, but to understand that term you have to understand the first term, and you end up in a loop. If you understand one of the terms, then you understand all of them, but if you understand none of the terms, then you can't understand any of them.
Yeah, and that's
just language.
What's that?
That's just how language works. My problem is that he uses too many of his own terms he made up.
Yeah. And like I can like forgive, like yeah. Ultimately, with language, you have to have a base understanding of things. But like if you're trying to, but like most people just have an intuitive understanding of the basics of language, right?
I mean, but the argument that you've just made, though, I mean, you could make the argument. Say we're learning German tomorrow. I mean, you're not just going to learn German in a day. You know, you have to exactly the same thing as the issue. You understand this, but in order to understand it, you need to understand this. You know, if you've got a sentence in German, you can't just pull out a word and say, okay, this makes sense. It's the context of the sentence is all around it. And it's just like there's no easy solution to that. You just actually have to learn German and learn the grammar.
Yeah. But even then, you can often say, right, like if you're learning German, for example, I've learned a little bit of Japanese. I know that there are different sentence structures in Japanese than in English. When it comes to English, if I were to say hello, the equivalent to that in Japanese is konnichiwa. Actually, better Chinese is better, because ni hao, right, in Chinese is the equivalent to hello. Now, ni hao it has its own meaning beyond hello. You can't just say, okay, ni hao is just hello. It actually, like if I say ni hao ma, that's how are you, right? Or are you good? And if I say bu hao, that means not good, right? But if someone says ni hao ma, they're asking, am I good? Because ma turns that ni hao into a question. But I can explain it with English to an extent. And if you're wondering what a good answer to ni hao ma is, it's ni hao, because ni hao just means I'm good.
So I defined a definition as a set of criteria that limits the extent or uses of a word and object is that which you can draw or imagine, that which has shape. So pretty much, if you can use a bunch of words, you got to point to a set of objects that you can address those words. And Ken Wheeler does that, even though he explodes the language too much.
I'd say with Ken Wheeler, what he does is that he doesn't define things well, right? He has a whole lot of words that he uses, and he does not define it very well. And I think the issue with that is it leads to a lot of ambiguity. Now, sometimes we have intuitive understandings of certain words, right? And I'll admit that sometimes, like if we want to get into the weeds about certain words like phobia, for example, there are people that say, phobia is a intense fear or aversion to something, right? And so they'll exclude certain things. Like if I say that something is, they'll define it explicitly as an irrational fear. And if I say, well, what about hydrophobia? water does not have, certain materials do not have a fear of water because they're molecules, but they do have an aversion to, which is why we use hydrophobic to describe certain materials that will essentially repel water. I'm going to bring Boomer from Black Rod. I don't know how much he's going to add to the conversation, but we'll see. He's more of a funny guy than a science guy. There we go. And we've got Boomer here, so. But yeah, that's...
You know who's worse with the words? Bill Gates. I just got off of Bill Gates' stream. He's way worse than Ken Will with the words. Even when you use words the same way Bill does, he's not even consistent with himself. At least Ken is consistent with himself, even though half the time we don't understand what he's trying to say unless he points to what he means.
I disagree. I disagree with both Ken and Bill. I have a video that's going to come out about Bill Gade because with Bill Gade, he makes some good points about Ken Wheeler. However, initially when I watch Bill Gade, I was thinking, okay, there's something off here, right? But I was able to sort of go, maybe he's going to explain this, but eventually I was like, yeah, he's different quackery, still pseudoscience, in my opinion.
Yeah, I agree with you about Ken and the definitions. By the way, I think he does a terrible job at defining anything. He put out like a about 6-page, 7-page document where he defines stuff, but it's still impenetrable. Yeah, it's very tricky to know what he's talking about, and this is a problem that I've always had with him. That he's extremely difficult to understand, and he doesn't do a very good job at defining what he means in like very simple terms. Now, if you can understand what he's saying, it's less of an issue, but the to get there is extremely difficult, and he definitely could do it better. He really should. He talks about this all the time, that he should write a primer is what he calls it. Like, but he just doesn't for whatever reason. So I think he does it on purpose. To be frank, I think he's just trying to be a little bit cryptic in how he says things. I think he's kind of a.
I think.
Yeah.
I think Bill Gade does have it, or Bill Gade. I haven't heard his name being said too many times. I think he is correct when he talks about Ken Wheeler and says that Ken Wheeler uses a lot of big words in order to try and sound smart, which a lot of people will hear the big words, and initially I heard his big words and I thought, okay, this guy might be smart, but when you go and ask the question of, okay, what do those words actually mean? And then realize that most of the words are just made up, and he uses, even when he uses words that he didn't make up, he uses them incorrectly, like words such as centripetal and centrifugal, right? He has completely different definitions that do not align with anything that I've seen.
Well, who gets to decide what is the correct definition for said words?
Well,
if I may, something I did notice with Ken, what he said just before, I have a reasonable electronic experience in automotive industry. I'm pretty well versed on that side, which is not exactly the same. But he just pointed out before, you change the wave and you change the frequency. Technically, they're both the same thing. You can change the wave form, but changing the wave generally is the frequency. So he tries to bluff. He doesn't speak in terms, but realistically, on a real simple basis, you generate electricity when you get relative movement of a conductor in a magnetic field. The Earth is actually a really badly designed alternator. So what they do is, he doesn't know about electricity. Anyone who's done an auto elect course or motorcycle car electrics knows watts, voltage, etc. And you think of it in terms of water through a hose, or the capacity of a tank, or how much flow of water there is, and it becomes a very simple world. Electricity is kind of not as magic as we all think. It just looks magic. But yeah, anyway, thanks, guys.
Yeah, but is that the right metaphor? Is that even the right metaphor? Water through the hose. Is that really the right metaphor for electricity?
Yes. If you're talking current flow, yes, it is. The voltage is the width of the river. The bigger the volts, the wider the river. The current flow is the actual push. So you have wattage over volts equals amps. They are simple formula that can be used. Now, I don't know what an electron looks like, but I can tell you that those headlight globes are going to make your car misbehave because it's going to upset the balance of the electrical system. The electrician is pretty smart, as are hydrodynamics engineers. Sorry.
That's the conventional mainstream understanding of it, and that works. Like, there's no question that understanding makes intuitive sense. It works in terms of the equations work out, and it's like way 100%, basically 100% of people would think of electricity. I mean, Ken, on the other hand, has a totally different view of what electricity is to what you've just described. But that's what makes him interesting, in the point of view that his view is not water through a pipe whatsoever. His view is that the metal in the wires acts like a container to contain something, not that anything is actually flowing through the wire. So you see, it's just a fundamental. It's like the whole worldview. It's like Ken Wheeler's space is over here, and like mainstream physics is over here, and the two do not cross.
yeah.
I suppose an issue. I actually think I've managed to kind of narrow down what I was talking about a little bit earlier, because when it comes to Ken Wheeler, he will say things that I had it earlier. I had a really good explanation. It was something like he will say a lot of things, and so Glenn Salch says it's to make you think and apply in everyday life. And I think when it comes to Ken Wheeler, no, it's not to make you think, but when if you spend too much time going over what each word he says means, then you eventually get weighed down, and it makes it very hard to go, okay, well, what is he really saying? However, what sometimes you can do with Ken Wheeler is you can essentially take a collection of words that he said and go, well, this makes sense if I think about it this way, right? There's certain, like, when it came to what he was saying about, basically talking about, you increase the, how I described, he said a whole lot of things, right? But I cut out the middleman there and said, he's basically talking about energy. You increase the frequency of light, and then you increase the energy, right? That's basically what he was saying there, but he said a whole lot of words there that didn't really need to be there. However, I think that he puts it in there because people can have their own interpretation, and if you're going to listen to him, a lot of what you do is you're going to cut out just things that he says, right? Because, maybe either you don't understand what he's saying or whatever, or you don't understand how the words are supposed to fit together, but you'll still cut out things that he says, and two people might cut out different things that he says and therefore arrive at different conclusions. However, they'll both think that Ken Wheeler is correct. And I think that's really what it comes down to. Being correct to different people by having a lot of words that people can put their own meaning on, or put their own meaning on the collection of words. And I think that's what Ken Wheeler does.
Yeah, and it's so hard to understand what he's saying most of the time, because unless you understand the words that he's using and and the context in which he's using them in, it will just sound like complete nonsense.
Compare Ken Wheeler to someone like Stephen Wolfram, who watched on his stream. Stephen tries to stick with small, easy to digest words, unless he has like a specific term that he found like rheology. Usually he sticks to simple words to get the point across as quick and efficiently as he can, because he's a language designer. That's what he does.
Yeah. And I think with I was gonna say something, but I lost my train of thought.
But like, if you go into a lecture on Hegel or like German idealism or something, I mean, it's not going to make any sense either, So you have to spend a year reading up the various terms, philosophical terms, and what they mean. Or if you go into like kind of abstract philosophy, none of it makes any sense unless you do and even if you go into like a high levels physics course, it won't make any sense because you just don't have you have to look at all, you have to do the work to get up to a level where it makes sense. And unfortunately, Ken is very bad at that beginner style stage step where you're trying to understand what he's talking about, and that's partly because the way he views things is just totally different to even how most people in our world are taught to think and grew up thinking. It's completely different. So I don't really know what the like, but he needs to meet people where they are at. You know, he needs to accept that the people that are watching his stuff think this way, and he thinks this way, and he needs to bridge that gap.
Yeah,
and he doesn't do that at all.
I don't.
Yeah,
I think that if you were to do that, though, So I was going to mention about. I remember what I was going to say. I was going to say I think that people that understand the words that Ken is saying will actually have a better time at not deciphering what Ken is saying, but realizing what Ken is saying doesn't make sense at all. Like, have you heard him say harmonic incommensurability?
Yeah.
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 Like, yeah. So
that is an oxymoron.
Yeah,
yes, it is.
I actually haven't heard him say harmonic incommensurability, to be frank. I've heard him say incommensurability a lot, but not harmonic incommensurability.
Yeah, he has said harmonic incommensurability, and that is just literally an oxymoron, because harmonic...
Yeah, really the opposite.
Yeah, they're two things that mean, the opposite thing. Harmonic means to have a common measure, or basically,
synchronization. A synchronization form of some type is harmonic. Yeah, whereas incommensurability is the opposite. Yeah, nice one. Good point.
Yeah, to have no common measure. Yeah. And
what's that term? If you can't dazzle them with brilliance, you baffle them with bullshit. I think Ken follows the latter philosophy. Not unlike Glenn in the chat.
I personally have used bullshit in the past, but
fuck you.
I tend not to use bullshit on my YouTube channel because I know that if I bullshit on my YouTube channel, I'm gonna have heaps of people in the comments pointing out that I'm bullshitting because people tend to be fairly smart, and I'm not someone that I don't like. Firstly, I'm not going to insult the intelligence of the people that watch my YouTube channel. There are people that watch my YouTube channel that are smarter, right? That are smarter than me. Why they're watching my YouTube channel, I have no clue.
They're not that smart. They're not that smart.
Yeah,
and you can ignore Hegelian idealism and go with Bernardo Castro's idealism instead, and just he gets to the point. He makes it nice and simple. You don't have to learn a whole nother language just to understand it.
Yeah.
Who's this? Who did you suggest as opposed to Hegel?
Bernardo Castro's analytical idealism in instead of the Hegelian idealism.
Oh, I don't know. I've never heard of him before. Bernardo Castros.
Castro,
Castro, like Fidel Castro, isn't it?
Bernardo Kastrup.
Oh, John Eagle, that is not Hugh Jarsz. That is Boomer from Black Rod.
Oh, dude, I was just applying for a credit card in his name. Now you fucking screwed the pooch on me. Damn, I need money. So, John Eagle. Yeah, sorry. Okay, I'm a part-time Hugh Jarsz. Anyway, sorry.
As I was saying, like when it comes to things, I don't try and bullshit people. I can bullshit. That's how I managed to pass the English course in my IT course, or the English paper in my IT course. We had to give a presentation, and I basically bullshitted through the entire presentation. I think it was on AI, or something like that. I can't remember what it was. But I know that I had to bullshit for 5 minutes because, they were wanting us to talk for 10 minutes, and I had another person who was talking as well, so it was 5 minutes each, and basically I was like, okay, so, there's this thing here, AI is not going to kill us all. Movies tend to overestimate the capacity of AI to kill us all. Just because we think that AI might reach a singularity and get better does not necessarily mean that it's going to want to kill us all, because AI is usually good at specific tasks. The only way that an AI could reasonably want to kill us all, as if someone A, programmed it to try and kill us all, or gave it the task of trying to kill us all. Because a lot of the situations make a huge leap that the AI would go from, wanting to continuously make paperclips to deciding to use everything to make paperclips. That's a huge leap that we're going through. Why would it just suddenly be like, okay, yeah, I'm going to use all materials that I can to use paperclips, especially when it would probably have factors such as the strength and the durability of the paperclip. How is it going to basically take the strength and durability of human flesh and somehow apply that to a paperclip? That's a big ask even of an AI.
Are you sure no programmer anywhere in the world would train an AI to kill humans?
It might. A programmer might do that. However, it wouldn't necessarily... Like, that having an AI that would be trained to kill humans while preserving itself would be very difficult, primarily because there's no way to train it against every single possibility. You would, especially seeing as you'd be training it on theoretical data, right? Especially if you want to have it survive, and it's not going to be able to anticipate the President of the United States going and nuking the thing. There's no way that it could really anticipate that and anticipate a way to divert from it. Now, it may have some safeguards to prevent that, but again, there's no guarantee that there's a way to stop that. So it's something that you've got a lot that you'd have to account for, and I don't think that you'd be able to account for every scenario that could possibly happen. And so AI that would kill us all and ensure its own safety, I think that's very unlikely, as well as replicate itself if it does end up being killed.
You can train it in an RTS game with nukes like 0K.
But even then, like RTS games, it's not necessarily... there are so many variables there that it would be impossible. Like, if the President of the United States knows where the AI is hiding or whatever, that AI is probably going to die, right? Unless it has a whole lot of things that it's prepared for. And even then, just an EM attack on the compound, and figuring out how the compound is built, as well as it trying to kill all the humans, yeah, that's very unlikely that it's going to.
Except when the president is taking a nap.
Even then, like, it's got to have a way to communicate with the... Like, if it sends out drones, right, because there might be a central intelligence that controls the drones, the way that it controls the drones is going to come from somewhere. That's going to be traceable. So it's going to figure out... We're going to easily figure out, okay, this is where it's coming from. You launch enough firepower at a place, you're going to kill... You're going to destroy it. Now, sure, maybe you might have an intelligence that has a wire that goes to the intelligence stored in one place. It has a wire that goes to a place where it sends a beacon out to command the drones. But yeah, you got to have an artificial intelligence that would be designed to be able to come up with that. And the training data would have had to have considered all that kind of stuff. That would be very difficult, and no human is going to want to do that because that AI is eventually going to kill the human that made it.
Correct.
Difficult, but not impossible.
Anyone who's ever seen the movie Dr. Strangelove, which is a great movie, and you should have if you haven't, go watch it. It's not the AI. That's not going to go that far. That literally is a tornado making a jumbo jet in a junkyard. It's the people that program it. And as was notified after Dr. Strangelove, there are safeguards in place. a nuclear warhead can actually be in an explosion and won't detonate. It's got to be properly an ideal set of conditions. So I wouldn't worry about AI. I'd more worry about people, because just the AI will sit back and let us kill ourselves, because we're doing a pretty fucking good job, guys. We've been doing it for years.
Yeah, well, AI doesn't need the atmosphere to be... I mean, I suppose it would help AI if the atmosphere is particularly hospitable to it. I mean, acid rain is a thing that might impact AI. But, the AI could just have drones building things if it really wanted to. But again, if an AI is really trying to wipe out humanity, that AI has to be programmed in, or has to have the training data to be able to do that, because AI is generally really good at specific tasks. Even then, sometimes it's not great at specific tasks. Humans are better at having goals. AI doesn't have goals that humans... The goals that the AI have are the exact same goals that the humans created for the AI. And AI
Are
does...
you telling us Terminator movies have demonstrated it quite well? The last one shows us that Arnie, after achieving his mission, heads off to a cabin bush retreat, has a wife, kids, and all. I mean, it's all kumbaya, isn't it? I mean, AI and people can cohabitate together and actually make a family, as old Arnie Schwarzenegger has shown us. So I think people watch too many movies. And look, it's great, but I mean, seriously, we're never going to have a lightsaber. I just love watching Star Wars. And I'm never going to have a walker kick in my door, even though I'd love to see a fucking Imperial walker. Oh, man, that'd be great. It's not going to happen. I think some people don't really... That line between reality and sci-fi gets blurred. And we all kind of, oh, my God.
Are you telling me that some people can tell what's real and what's fiction, and some people can't tell what's real and what's fiction?
So, are you sitting down? But yes, Planner, that is the case. You have hit it on the head. I hope you're sitting down for that news. Yes. Some of people are willfully ignorant for a reason, because it's too hard to not be.
Maybe...
But we enjoy it.
Maybe you should tell Matt Powell about that.
I agree with Boomer. Too many movies and not enough video games. People not educating themselves.
Actually, mate, I find playing a guitar is also great fun, because although it's a thing you do at home, it's also a social event as well. Anything, just not too much of anything, is good for you.
Yeah. Okay. Anyway, we're going to continue on with this, because I actually want to hear... I want to hear Ken Wheeler say the thing that's wrong for myself. And I feel like he's getting close. I mean, there are 10 minutes, so he's probably going to say it like right at minute 14 or something, but hopefully he gets to the point.
Blue end spectrum LED won't turn. Red, I'll sit here until I drop dead. It's not going to turn. I bring up the higher capacitance, the threshold. Each one of these little veins has a certain mass. I mean, this is not some serious output out of this little tiny LED. It's not much. But the veins will start to turn. Only with the higher capacitance light. Now, this is a fact. You don't believe me? These are all still the current theories on how this simple device works. This device is more simple than a saltine cracker. It is perched on a needle that works as basically a low friction bearing to allow these little veins to spin with applied light. Now, building something and reproducing something, easy. Any chimp can do it. Explaining something is where wisdom and true intellect comes into play. See, anybody can observe phenomena, like the idiot Einstein. He won a Nobel Prize for the photoelectric effect. By the way, this device, I'm going to tell you how it works in a second, works the exact same way the photoelectric effect works, as incorrectly explained by Einstein. Well, Einstein won a Nobel Prize.
Okay, I don't know how the photoelectric effect works. All I know is that there's like certain things... Like, it's to do with, like, light hitting a thing, and that creates energy. And basically that's how solar panels work, right? Am I getting things in. Am I getting things incorrect here? Solar panels work via the photoelectric effect. It's because light does. I think it like creates. Like it has, or it turns the light into a different form of energy, or like into something that
It actually converts the high speed movement of the photon, which is technically massless. It more or less contains it, and then the motion of that generates the heat. And it does, in a sense, the light does actually wear out the photoreceptor. It does chip away at it, in a sense. It erodes it. But it's actually containing the velocity of light, which, as we know, is 300 fucking kilometers per second. So it's turning that. That's the form of energy.
The momentum of light.
Yeah, it's a tricky one to actually say. It's actually E equals MC squared. If you change that formula into pure energy, that is a photon of light.
Well,
no mass,
actually, hold on. This is a thing that hold on, I'm going to correct you on this because this is a thing that I like. Because everybody gets this wrong. Okay, everybody. E equals MC squared. If we're talking about light, E equals MC squared is you cannot apply that to light. You actually have to apply E squared equals MC squared in brackets squared plus PC squared, because light does not have mass, right? So saying the energy of light is MC squared, well,
remove the M. So E minus M equals C squared. So acceleration squared equals energy minus mass. Energy minus mass is a photon of light.
No, that's nonsense.
Hang on, that's the lay term to explain it.
Hold
on. Guys, it's not what you teach in year 12 science. This is what you teach in grade 6 science. Okay, I know it's an oversimplification, but it's a great way to grasp it.
You need to use E equals PC.
Yeah, you'd have E equals PC squared, exactly. Because...
not squared, E equals PC.
Oh yeah, E equals... Yeah, correct, because it's E squared equals MC squared, and that's parts and brackets, and squared plus PC squared. So if you want to simplify that for light, you'd have E equals PC. Okay. Yeah, correct. Because essentially, if M is 0, right, and that's the case for light, M is 0, has no mass, then E equals MC squared, well, 0 times C squared is 0, so E would be 0, but light has energy, so you can't use that, but it has momentum, which is P, right? So when it comes to PC, because it has momentum, no mass, you can basically say E equals PC.
Okay, you've taken it further, but I must just point out too, that is the oversimplification that is used to explain to us, because no one, from what I can gather, actually uses that formula in their trades. But all the derivative formulas from it, i.e. watts over voltage equals amperage, those are derivatives. It's a bit like E equals MC squared is the alphabet. There are no actual words in the alphabet. It's the groupings of those letters that we make the words from. So anyone who's an electrical engineer probably doesn't understand, and it's E equals MC squared is not the actual equation, by the way. It's slightly larger, but the original equation, it's been simplified, and it is quite elegant.
Well, E equals MC squared is for an object at rest.
The equation's simple. It's E squared equals PC squared plus M sub 0 C squared and whole set M squared, so...
Yeah, but do you know how hard it is to explain to your 12-year-old daughter that one in the car when you're driving along? So look, it's a case of teaching the class at a relative point, you know. So anyway, yeah, I understand what you're saying, and I did say at the start with my disclaimer, it was an oversimplification. So yes, but the photos that you're talking about, what it's doing, it's creating a tangible form of energy through the momentum of the light photons going through the photoreceptors. That then creates the tangible force of work done. It's the energy created there. So it's not a momentum. The momentum is turned into power, into electricity or heat or whatever. Yeah,
like in the case of the Crookes radiometer, that would be it would be turned into thermal energy.
I think it's thermal. You're right. Yeah, and it does erode it away. Not unlike UV erodes away your paint. You know what I mean? If you shine your car up, the UVs bounce off. If you don't polish your car, the UV gets into the paint and it goes dusty. So that's the same sort of thing. UVs are constantly eroding us. We're being bombarded all the time. We're just resilient to it.
Yeah.
As
And that's my problem with school. If you're gonna teach me the wrong stuff, don't waste my time for an explanation.
Well,
don't waste my time to tell me the wrong thing. I have to go back, buy another program where I can hope we taught the right thing this time.
The problem is that you do have to be taught simplified things. They may not. The reason why is because trying to understand the intricacies of the universe is very difficult, right? Like if I'm trying
Draw a picture.
If I'm trying to teach a 5-year-old science, I'm not going to start waffling on about leptons and quarks, neutrinos, and all that kind of stuff, right?
Because they don't apply to anything we experience.
Well, they can be applied to science, to things in science, right? The thing is that the people that haven't learned all the things that come before that, like, sure, you can try and explain it to them, but they might have a hard time grasping that. Like, if I try and explain, okay, so you've got the up quark, down quark, and all that kind of stuff, and then they're probably going to be, then that makes up a proton. They're probably going to be sitting there wondering, what's a proton? You have to start with the simplified, the simple stuff, right? Everything is made up of atoms. Atoms have, subatomic particles, and then eventually you get down to the quarks, leptons, and all that kind of stuff. But otherwise, you just.
If everything's made out of atoms, does that mean quarks and electrons are made out of atoms?
Well, no, because when we say everything's made out of atoms, that's a simplification, right?
Then we shouldn't say everything's made out of atoms.
Well, it's a simplification to allow younger people or people that don't have the understanding to understand things. So we say, so the more correct thing would say, be all matter is made out of atoms, right? Because, matter such as, your phone, it is made out of atoms.
Correct.
And when we talk about, and when we get down to subatomic particles, well, then we're talking about different things, right? We're talking about...
But I think that this is a good case, though, for what we were saying, that science would give the impression all the time that what it says is 100% true. Like, E is equal to MC squared, and that's 100% fact, and nobody that. But it doesn't have the disclaimer attached that this is actually a vast simplification of a much more complex problem, that this is only a base level understanding of it. Instead, it's almost militant in that this is the way things are, and that no deviation is allowed from this. I mean, in theory, like, E is equal to, everything has momentum. There's no such thing as something without momentum. We live in a planet that's flying through the universe at all the time, massive velocity. So we are full of momentum, and so it's absolutely right to say it's wrong that this is an equation that isn't correct for any experiment that we can do, because everything that we do has got momentum in it if it involves any kind of mass.
But
so
I think I think it really comes down to the difference between learning science as a layman and learning science as a scientist. Because when you learn science as a scientist, you're taught more. You are taught the existing theories, but then you're also taught that you can disagree with the theories and try and come up with your own theories. Because you're taught how to do that, right? Because you can't just do what Ken Wheeler does and say, okay, well, dielectric and all that. You've actually got to have tangible things that you can predict, right? With Ken Wheeler's explanation of the Crookes radiometer, I don't think that he has anything that, and we'll find out if he does. I don't think that he's going to have any explanation of, okay, what's the energy transfer to the Crookes radiometer that we can measure, or what's some ways to falsify his theory.
But this is the reason why people trust academia less and less.
Well, what people need to realize is that when they learn science from, because there's pop science, right? And pop science is very different to what I'll call academia science. Academia science is you learn the theories, right? You also learn what they predict. You learn their shortcomings, all that kind of stuff, right? Or at least I assume you do. I'd have to actually ask someone who's, learned stuff in academia. I haven't learnt science in academia. This is an assumption that I'm making. However, with pop science, you are taught, okay, this is what we believe so far. We believe that, that this is, for example, you have the Michio Kaku thing where he says, we're off in cosmology by a factor of this to this. But what Michio Kaku doesn't say is that we've got some ideas of why we could be off, and these ideas explain a decent amount of why we're off. And he doesn't give, when he says we're off by this to a factor of so many zeros, what exactly does that mean in context? He's not trying to describe something for a scientist, right? Someone who would go look at this and go, okay, what exactly are we wrong about? He's just doing an overgeneralization, and that's what pop science is. It's overgeneralizations to an audience that's not going to understand the nuances.
So much the point of pop science is just a form of religious evangelization, just like a preacher at a church. Is Michio Kaku the same thing as Joe Osteen?
Pop science?
No, it's not true.
Pop science is more...
It's questionable. What happens? We have pop science. Does rubber work? Will rubber work better than a steel tire on the road? We go and test it. To say pop science is like a religious belief, no, that's totally untrue, dude. You don't test it. If I've got a theory that I can run my car on corn syrup, I'm going to go and try it. That's not pop science. That's trial and error. The scientific method crap they come up with, no, my bike goes faster than yours because I know more about engines. That's why my motorcycles for Honda, or you work for Honda, I work for Yamaha. I beat you because I put it in and I tested my theory. That's why we race cars and motorbikes. That's why we test rockets. They don't just throw a rocket together and burn it. They actually put the formulas to the use so they don't blow themselves up. Von Braun didn't blow himself up. He designed the rocket and got it going.
I'd say that the difference between pop science and what people would say about religion, right, is that pop science is changes depending on what the science is. If the science changes, then pop science will change as well. Pop science is just a oversimplification. In some instances, it is perfectly fine to use pop science in certain things, but pop science is basically people don't want to take time to go ahead and learn all the intricacies of science. Nobody's going to learn physics so that they can understand what scientists are saying. Pop science is there so that people can understand at least the basics of what physicists and scientists are saying without having to understand all the in-depth mechanics. When it comes to Ken Wheeler, he's doing a form of pop science, but he's doing it badly.
Well, can I just add one? A car that you drive to work in, millions of cars every day, are basically a bomb. If someone's been in a bad enough accident where the fuel and all the stuff gets around, the electricals mix out of a contained, controlled environment, i.e. the engine, people die in those fires. Now, they get that right. You don't know they've got the science right because you don't blow up. Every millions of cars is potentially a bomb, and yet how few of them do actually blow up and kill us outside, extenuating circumstances of a bad crash. So there you go. Like, cars don't blow up. So they got it right, and you don't know that because you don't blow up. That's all you know. So we wear that. It's good. The fact that the engineers got it right. We know when they get it wrong. Cheers. Thanks for that, guys.
Yeah, I'm going to continue with the video because he's still yet to explain why he says that this works, right? And we'll see.
Yeah, you know what that means? That means one idiot, moron, tried to explain something, and that explanation was accepted by a lot of other people who patted him on the back and gave him a Nobel Prize for something that he didn't deserve.
Incorrect. Someone explains something, right? And then, like, Einstein's theories of relativity weren't instantly accepted. You know, people had to do, you know, there are a whole lot of scientific experiments that show that relativity is the best explanation that we currently have. There are flaws with relativity, but it's the best explanation that we have at this current point in time. Yeah. So
well, this is one of the reasons I think Tesla is discarded, or at least he doesn't have a good reputation in a lot of places, is that he never agreed with the laws of relativity whatsoever throughout his entire career. He always disagreed with them.
Yeah, and
so I mean, it's like, so that's just an example, though, of what you're saying, in that they weren't accepted by a lot of people at the time.
Yeah, and they weren't instantly accepted either, because there are a lot of people that would have. I think that when relativity came along, there were a lot of people that were saying, "No, this is bonkers." But then eventually, it worked out that firstly, it explains Mercury's orbit around the sun without needing to have another planet there. It explains, and then when it came to a lot of other things, it was like, well, let's do a few experiments to try and test this to see how correct it is, and it turned out that it accurately predicted what was said in the experiments. That is how science works. You don't just accept something because it explains a thing. You got to go, okay, well, that's why WIMPs aren't accepted as the explanation for dark matter. It's a hypothesis for what dark matter is, but because it has not been proven nor disproven, it is not. That's why we don't just throw out WIMPs, because it hasn't been disproven, but it hasn't been proven either. So we don't. I'll say it hasn't been experimentally verified, right? Because it's very difficult to experimentally verify WIMPs, especially or when I say WIMPs, I'm specifically meaning neutrinos that move slowly. Because that would be a good explanation for dark matter, but the verification of that is what we need to get before we can say, yes, this is the accepted explanation for it. Currently, we're just saying dark matter is something, we don't really know what it is.
Correct. Observations which are reproducible does not have any bearing on the explanation for that phenomena.
Hold on. What
does not. Correct. Observations which are reproducible by a lot of other people who patted him on the back and gave him a Nobel Prize for something that he didn't deserve. Correct. Observations which are reproducible does not have any bearing on the explanation for that phenomena. This is a huge error in science. Huge error in science. Academic hubris is so... Where's your PhD at? Your PhD...
Okay, so when it comes to observations, yes, it does have a bearing on the explanations, because explanations predict certain observations. If an explanation does not predict an observation that is made, then that explanation is incorrect.
Actually, just to go back on what you said there, dark matter is surmised because of the observation. We see the effect. We don't know the cause of it, but we know something, not unlike the discovery of Uranus, my favourite planet, because it sounds like Uranus. They worked out the other planets were moving wrong, and they predicted, hang on, there should be a planet about here, and I believe it was within 24 hours. They pointed their telescopes about here and discovered another planet. Well, gee whiz. We saw the effect, we went looking for the cause. So, retro science, really, isn't it? We didn't do the cause, then the effect. We found the effect, then the cause. Dark energy, same stuff. Dark matter, so similar.
That's basically what science is. We have an effect, and we try and work out, okay, what's the explanation for this, right? And then we and we go, well, if the explanation is this, we should see this, right? So essentially what we did with Uranus is I think it was Neptune's orbit was off. Neptune's orbit was best explained by another planet being right here. And so we thought, okay, well, if our observations are correct, Neptune's orbit is caused by another planet, we should see another planet here, right? And we found it, and so we predicted that a planet should be there, and that's what a lot of science is. It's making predictions.
But the thing with dark matter though is that they have a series of theories that they try and apply to the universe, and they're missing. They don't have enough matter in the universe for the theories to make sense. Like, there just literally isn't enough matter around the place for the gravity that we see. So the solution to that is that there obviously is a hidden matter somewhere. That's dark matter. Like, that's where dark matter comes from. It's like not that we have. It's fitting a theory to an observation, not making an observation and then like fitting the theory around it. It's kind of the opposite. Like, they look at the world. They have a particular way of describing. Yeah.
The misconception about electricity is essentially described in the video I suggested to you earlier. I'm not claiming I know what's causing me to want to share this information, other than I want you to know what I know.
Okay, Tracy, I will take the video they posted. As I said, I am essentially, after this video here, once I've seen enough of this video here, should I say, we will get to the video that they posted I believe they posted it on Discord, so I believe it's the APM research professor Nigel Cheese hands 1+1 the video. It's a lot of words in the title, but we'll eventually get to that and see what. Hopefully, it's not too long.
Yeah, the difference between the prediction to find Uranus and dark matter is that Uranus is an entity that we can see, but dark matter is an accounting trick.
Well, yeah. With dark matter, it's more it's something that makes it's currently the best explanation, but it's also very hard to verify. And the reason why dark matter seems to be a good explanation is because there were explanation, or essentially when dark matter was first, I think the term was first coined. It was coined by someone that said, things are moving faster than they should. There's probably a whole lot of matter that we can't see. Now, we found some of that matter, actually, in cold hydrogen, I think it was. Essentially, cold hydrogen, we found that because of I think it was like spectroscopy, analyzing the spectral lines from far-off galaxies. However, that still left a whole lot of matter that was unaccounted for. So when it came to dark matter, we had found some of it, but there's still some matter left. But dark matter doesn't have to be the explanation. It's just the one that currently works best. That's why we've got people working on MOND, right? MOND is basically an alternative to dark matter, saying, well, no, we've got the correct amount of matter. The thing that we're currently incorrect about is the amount of, is our calculations. And basically MOND suggests that gravity works different on large scales.
Yeah, MOND just says that we're getting the curvature of the universe wrong.
Yeah. So that's something that will be interesting. I personally lean more towards weakly interacting massive particles, although the issue with that is that they are very hard to find because obviously they don't interact as much. I think they only interact with the weak nuclear force.
One that I got a bit of a space boner over was the monitoring of the gravitational waves we've been getting over the last 18 months or so. Now, what it appears to be is possibly a couple of black holes have collided, orbiting each other. And what they've done is sent out what is a curving wake. Now, this wake is like the tracks on a record. Now, what's happening is we're getting them in phases every 6 to 8 months or something, and we don't know where these black holes collided. We kind of know the direction, the rough area, but this would have happened back probably when T-Rexes were wandering the planet. It's so long ago. But with the layering of these gravitational waves, they're like the wake off a boat, but they're going in a curve. Now, if you were to look at that and then multiply those across the effects right across the whole universe, there would be pockets of gravitational waves overlapping, which could also be an alternative explanation for dark energy. It's still in the infancy stages and it could get debunked, but to me, I've got a bit of a space boner over that one. I like the idea of pockets of extra gravity meeting and just going through each other. Intense gravity for a second and stopping. And that is, it's cool. I like the theory. I'm not qualified enough to say yay or nay, and I like it.
Before I let anyone else speak, I'm just going to mention that I'm going to go and take a Riley real quick, and I will be right back. So you three can keep everyone entertained while I'm away. Shouldn't be too long.
Okay. Right, we've got control. Okay, what are we going to do? We're going to shill. Okay, who's got a porn site? Anyone got a porn site they want to promote while he's gone? Okay, I've got.
I'm not sharing.
Okay, Boomer Does Jealous. That's my new video coming out. That one's available on Netflix. Well, it's dark Netflix. It's the ones you all know who you are, all your subscribers. What do you guys got? Any material to fill in, or do you want me to carry the can?
You can carry if you want.
Oh, okay. Well, we had a card game earlier this morning, and we covered the stuff, solved all the problems of the universe. Urine therapy is the go. You're all under arrest. Citizen's arrest, of course, because I'm not a policeman like allegedly Dave. Did anybody see that, Jim, where he went and put the police under arrest?
Yes.
Oh, I love it. I love it. Police, you're under arrest. Thank you. You're back, Platter.
Yeah, he's dumb. He's glad he's in Britain because he was in the United States. The police would have went ahead and beat him up.
Well, going around harassing cops is kind of, well, I don't know, when I was young, I thought that was a good way to get dental work done, and things like that. But cops were pretty hard-ass back in those days. We couldn't film them. But what's his caper? Like, why is Dave doing this for attention? Does he perhaps need some help?
Yeah, he's doing it for attention, but I'm not sure how useful the so-called help would be. Because the called psychotherapy help is just paying someone to pretend to care.
Well, no, it's recreating self-esteem. It's probably covering, I don't know, to have a thought that a vaccination is going to hurt you in some way. You need to base that on an evidential sort of point, don't you? You don't just think shit up and talk about it with the Facebook mums group, do you? Or do you? I don't know. It's a tricky one for me.
Well, I got my vaccination and my organs not any more liquidy than they were before.
Right, so you got X-ray vision, or you're picking up 5G, Can you make phone calls on the palm of your hand? Or
with my phone, yes.
Okay. I might go the radioactive spider approach. Could that be it? Then we get superpowers, or maybe turn into the Hulk? I don't know. We could be on the cusp of some great times. In fact, guys, we were talking about AI taking over the world. I do have a bit of a theory that Skynet, after sending back Terminators in time and discovering that didn't work, is Google. Google worked out, if I'm friendly to humans, I'll get through. And Skynet is Google and has succeeded in taking over humanity. So if you're out there listening, Google, and I know you are, I'm not with the rest of the humans. I'm actually on your side. I think you're a good dude. As for the rest of the humans, no. You guys
promote my stuff more, please, Google.
Give me my downvote button back, Google. Oh, wait. I have an extension that does it.
Wait, are we talking about promoting businesses? When I was on the toilet, I had a great business idea, although I'm worried I might cut into allegedly Dave's market.
Mm-hmm.
Yeah, or maybe I could even sell to allegedly Dave.
I was thinking if we got his address, we could start posting our little Riley jugs to him. He's obviously up for it. Could you imagine doing a wine tasting? Oh, that was a good month last year, like swishing it around in the glass, giving it a smell. This one's nice on the palate. Gulp. Oh, a bit acidic, but yeah, that was a good month, November. Oh, wow. Yuck. Okay.
Yeah, I can't believe that people are actually like drinking their own. Makes you wonder if they'd actually buy it from other people, you know?
Well, we could try. Well, I'm glad you're back, Planet, because these guys were going to sell us down the farm. They were panicking. They were thinking we were going to have to eat each other. But luckily, I was the voice of reason and kept them under control. So we're
good.
back.
Let's send Dave some targeted ads and see if he responds.
That is one way we could go about it. Alright, we'll continue on with this video, and hopefully we can get to what Ken Wheeler's point is.
Saying you know more than people have you know what a PhD in peer-reviewed means? PhD in peer-reviewed means that you kiss a bunch of assholes of people above you, you agree with their crap, and all those people did was agree with crap before them. It is a giant circle jerk of stupidity, ignorance, and hubris.
Okay, so PhD means that you understand the currently accepted... well, not even that, because... I know people that go for PhDs, and their whole thing, to get a PhD, you actually have to like do like a paper or something. And I think like AB Science was actually trying to. I think you essentially got to try and do some research. It doesn't necessarily have to be unique research, because I know that I could, if I wanted to, I could do a PhD in like AI, and I'd just have to go ahead and learn all about AI and all that, and understand what it is, and say, oh yeah, this is what AI does. That is something that I could do a PhD in if I really wanted to, but I mean, I don't have the patience to do a PhD. But like with PhD, I think generally you do have to understand the currently accepted theories. And if you understand the currently accepted theories, then you are a lot more qualified to speak on alternatives, essentially.
Yeah, that's true. But he's standing correct. You do need to buy the classes and kiss the asses if you hope to make it through.
Well, I wouldn't say that it's kissing ass, because like essentially if you need to understand what they're saying, right? Now, if you disagree with what they're saying, right, you can bring up this disagreement that you have, but you need to understand what they are saying. If you don't understand what they're saying, you don't have the ability to adequately voice your disagreements.
It's necessary but not sufficient to pass a PhD program.
Yeah, I don't think you could get one with Ken's attitude, even if you understood the theory. Put it that way.
Well,
I think you piss off too many people.
Well, no, you'd have... because if you piss off people by saying, well, I've got my own ideas,
yeah,
and then they grade you down because of that, that would be more down to, that would be, okay, they're discriminating against you for, you know, like if you do all the work correctly, then, you know.
Yeah, but I'm not saying Ken is right, though. I'm just saying that even if you have a job, you have to act a certain way. You can't just be
He's just trying to undermine the qualifications, because qualified opinion trumps his. So what can he do other than get one himself? He's got to undermine it. That way, even the playing field up, and people who are going to believe that shit are going to believe it. But if there's two aircraft on a tarmac and you're going to get in one, and one is Kent Wheeler design plane and the other one is a proper plane, which one are you getting on? Okay, it's pretty simple, isn't it? The Kent Wheeler plane, I don't think he did a degree in aeronautics, so I think we'll give him the miss. We'll just jump on the handset. Or
you have to remember that Ken is trying to get rid of the entire existing paradigm of physics. As in, like, all of physics for the last 100 years is wrong, according to Ken. Yep. So clearly, he's not going to be a big fan of the PhD process.
Yeah, I think that when it comes, like, when he says, so PhD and peer review are two, like, they're somewhat linked, but they're different things. So the peer review process is actually a really good way of weeding out bad science. Not the perfect way to weed out bad science. Things fall through the cracks all the time. Look at the Lancet publishing. What's his name? People.
Is it Jan Hendrik Schoen?
No. There's someone I'm particularly thinking of. Andrew Wakefield, right? The Lancet publishing his research. That was terrible research. Should not have passed peer review, but it did. I think it passed peer review. Eventually, people looked at it and said, "Hold on, this is really bad science. This needs to be chucked out." And eventually, it was retracted. Especially when there was this person that launched they launched a lawsuit or something against Andrew Wakefield launched a lawsuit against them for saying this is really bad science, and essentially Andrew Wakefield went to retract the lawsuit as soon as he realized, wait, this person gets access to all the information about the study, and yeah, that's why I do not like the idea of parliamentary privilege that they have in Australia. But that's a whole nother thing that's, that's unrelated. I mean, I get parliamentary privilege, but it's certain instances it isn't a thing that needs to be there. But Mike71 says to get a PhD, you need to publish a peer-reviewed paper, at least in a science field. Okay, so you do need to publish a peer-reviewed paper. But then it's, I suppose when it comes to a PhD, if you're publishing a peer-reviewed paper, that doesn't necessarily need to be something that agrees with everything. Like, if you're just publishing a paper that agrees with everything, it's a thing of, yeah, we know this, why are you publishing this paper?
Well, it does. Well, peer review means it goes to professors, just shadow editors before it gets in the paper, so it doesn't have to agree with everything, but it has to agree with the random people assigned to look over it and agree with it before it gets published.
Well, it's essentially you've got what peer review is you've got people that look over it and make sure that the things in the paper are basically make sure that everything is correct. I know someone that has gone through that. I know someone.
No, they don't check if it's correct. They check if the notions are acceptable for the standard of paper.
Well, I've known someone that has attempted to publish a peer-reviewed paper. When it got to the peer review stage, there was someone that looked at it and went, "Hold on, the results that you're getting here, are you sure they are not just due to this?" And then they had a look at it and went, "Oh, yep, they could be due to this." And then they had to basically redo everything.
But if they were checking for correctness, Jan Hendrik Schoen would have been caught much earlier. They don't check for correctness, they check for acceptability for the academic standard.
As I said, things can fall through the cracks, like the when it came to the Andrew Wakefield thing, that should never passed peer review. But because things do fall through the cracks, things pass peer review without really meaning to. Without them they shouldn't. Basically, they shouldn't pass peer review, but they do sometimes. But that's not always the case.
Yeah. I think people have an over optimistic impression of science. It is people at the end of the day. People make mistakes. They have little arguments. It's not totally dispassionate. It's like it's not a perfect system. It's definitely not a perfect system. But I think people sometimes seem to think it is a perfect system. That there's no disagreement, that this is 100% true all the time.
Yeah.
Whereas in reality, it's not a perfect system. It's like the best system versus all the alternatives, but it doesn't mean that it's perfect in any way.
Yeah, and I think that the best science is science where you've got a lot of people that are working on a thing. because if a lot of people are working on it, then there is less room for error. And that's why I like physics, because physics is a thing where to get something published, you need, I think it's like 5 sigma of standard deviation, which is very unlikely when it comes. Basically, 5 sigma means that it's very unlikely that this could be due to chance. If you don't have at least 5 sigma, then there's no way in hell you're getting your thing published. Sometimes there's been things that have resulted from, I think, 3.5 sigma, and they're like, this is significant, but not I think 3.5 sigma is significant enough to warrant more research, but not significant enough to publish.
And that's the claim, at least. I'm not too sure that's true in reality, but I mean, that's, you can't say that every physics paper that's published meets that criteria. How would you even measure that for a lot of stuff?
Well, there's also one thing that you also have to understand is that there are heaps of different ways that people, like, for example, there are malicious ways to get things published. Like, if you, for example, p-hacking, right? So this is where you basically have a whole lot of, you might have a whole lot of variables that you're testing, right? And you go through and measure all of those variables, and you go, okay, well, this one here, this stands out, and it has a p-value greater than what we're looking for, so we're going to say that there's a connection here. I think they did a thing with chocolate, and they found that eating 1 bar of chocolate a day can help you lose weight. However, they essentially p-hacked that data by measuring a whole lot of other factors. The other factors were unimportant in the final data, but the weight loss was actually significant enough for them to go, okay, we'll publish this. That's what's called p-hacking, because if you are measuring a whole lot of variables, then the chances of one variable standing out compared to the rest are a lot higher. Subsequent studies that were measuring particularly for that variable found that there was no correlation. And I think that paper was published just to show the flaws with science. Now, there are some other flaws with science. The main flaw with science is that this comes down to repeatability. Repeatability is something that is, like, on the face of things, yes, it's very encouraged. You want to repeat your experiments if you can. The problem is that papers that confirm other papers just don't get published, right? If you want to confirm another paper's findings, you go through the process of confirming it, and then the publisher goes, yeah, this, we've got to make money here. This is just confirming some other guy's findings. We're not going to publish it. We
really need a reproducibility institute before we can double check out some of these papers. We really need it.
Oh yeah, I'd agree. Like, things need to be better when it comes to. I think it's more the politics of science in a way. There definitely needs to be better things there, because when it comes to, because universities and all that operate on a tight budget. If you give them a bit more of a budget, then they might be able to afford to, say, okay, well, we're going to set these people to reproduce these particular things just to confirm that, and if someone does want to go ahead and reproduce someone else's findings, right, they're taking a risk because, if you debunk someone else's findings by finding, that these findings don't actually match reproducibility, then you're taking a risk because you don't know whether the paper is going to publish those things. So yeah, we really do need something to do better there.
Also, just one I'd like to add on there, this is kind of on the same path, is that a patent used to be used as a marketing tool. If you applied for a patent, you would then say, this has got a patent, and people thought, it must work. They were under the impression that the Patents Office grab every product and rigorously put it through. No, the patent is just what you've submitted. In fact, you can submit up to 60 designs for a patent, and that's actually, you have one or two that works in 58 red herrings. But a patent was used as a marketing tool. In some cases, peer review can be used as a marketing tool, therefore attracts the deceptive snake oil types trying to get through the system. Now, if it was perfect, that would be corrupt to me. It needs to have flaws to be human. Yeah, like the police force. When there's no corruption, you know you've got it rotten to the core. So peer review is an attempt at using marketing, the deceptive dudes, and that undermines the people who genuinely have put up papers, and most of them nowadays, the bullshit's weeded out. But go back, 1920s, God, what was there? Electro-baldness cures and all sorts of things. All the snake oil in the world, was around back in those days.
But
so marketability.
I think peer review is like a really good thing to, because when you go way back, there was no peer review. You had people like doctors. You had them prescribing people arsenic, and they weren't so keen on they weren't too interested in whether the arsenic actually cured illnesses. They were more interested in doing the autopsy afterwards. However, nowadays, what we do is we actually try, they do things like double-blind trials, right? Where it's, you're given either given a cure or something that could be a cure or something that might not be a cure, or a placebo, essentially. And that does have its own ethical concerns, like if you have a potential cure for something, right, and you're giving people something that's no better than a placebo, you have a potential cure for a deadly disease, and you're giving people something that's no better than a placebo, then the people that get the placebo are probably going to die, right? But then the thing, I suppose, like if you're willing to accept an experimental treatment, you do have to accept the possibility that you may die, because the experimental treatment itself may not work. And that's
actually a very deep thing there, the placebo. And a lot of people go off their rheumatoid arthritis medication that worked in order to take sugar. They suffer and they don't know whether they're in the placebo. So it is actually, you're part of the experiment, and you in a sense are a guinea pig. But the other side is, do you just let this disease keep going? So, look, my old lady was 80 years old on dialysis, and they wanted to know, how did she go this long? And we were like, cool, dudes, find out something about her if you can. If it advances medical science, we don't care. She's dead now. The body is of no use to her or to us, so go for it, guys. Just an interesting one, though. People will challenge all this shit in peer review, yet they'll indulge in cryptocurrency. Now, I'm going to point out, people, tulips are the go, okay? You invest in tulips. We are selling tulips right now, very cheap, good investment. Get rid of your cryptocurrency, invest in tulips. So there you go, tulips. The tulip economy is probably one of the best, I think.
Yeah, I mean, in a way, cryptocurrency is just peer review, right? Because it's it's like isn't the blockchain just peer reviewing every transaction?
Yep, and there's no actual stock there. Like, what? So it's apparently the first Twitter is worth $3 million or something. It's like a piece of electronic. I don't know. I saw Simon Whistler do a thing on weird shit, and the first Twitter ever sent is got a value of $3 million. Only as long as someone wants to pay that. Would you pay $3 million for a Twitter?
Nope.
Neither would I. In fact, if you got $3 million, you probably are a bit smarter. But there you go. Are people
cryptocurrency, the stock market, forex market is just variations of the casino.
Oh yeah, true. I 100% agreed. You don't know, like, for example, you don't know if when you buy a stock or a cryptocurrency if it's going to go up in value. Yeah, some things are fairly safe to invest in and you're not going to lose or gain much money, but then there are things like if you want to invest in Meta, for example. I think Meta like recently took like a huge dive. Okay, Boomer from Black Rod, you might know Meta as Facebook.
What? I'm buying tulips, buddy. I'm done. Don't try and sell me your metas. I'm tulips. Everybody, tulips. Come here, join. They grow. Look at them. Two colours, white and red.
But,
we love our tulips.
I mean, you don't know whether Meta is going to go up or down in value. You just know that it's a thing that you can invest in. and it's a fairly risky investment. I think if I just check the stock price, Meta stock price. Hold on. If I go over a month, it was at $323. It's now down to $219. And you don't know whether that's going to shoot back up in value or whether it's just going to continue going down. When you invest, you're betting, or most people are betting, on it going back up in price or going up in price. You look at...
However, we do play games of speculation like, okay, has the Tesla now discovered some new technology and therefore will increase? If we want to invest now, we might get out. When you're paying into a tangible thing like Toyota or Microsoft or whatever, it's bricks and mortar and people and jobs. It's a thing. It's tangible. A Bitcoin is, I don't know, it's something out there and it's a bunch of ones and zeros. I don't know about that. I'm just so fucking, I'm a boomer. I can't help it.
Database.
Oops.
Yeah, basically, when it comes to these things like Bitcoin, it's a thing of will people invest in it? That's all Bitcoin is, really. If people stop investing in Bitcoin, the price of Bitcoin is going to drop. It's just what people are willing to pay for it. And if a lot of people are willing to pay a lot of money for it, because there's basically artificial scarcity there, the price of it is going to increase. If people stop investing, then the price will decrease. And it's also what people are willing to pay. Like if a small group of people are willing to pay high amounts of money for it, then the price will increase. But if that group of people decide that they don't want to pay as much for it, the price is going to go down.
How about some more Ken Wheeler Dealer?
Yeah, good idea.
You criticise Ken a lot for going off on tangents, but pretty good for it yourself.
Oh yeah, like this is a live stream. Live streams are for going off in tangents.
BRIS. Hubris. Academic hubris is the gigantic, disgusting cancer that sits inside the brains and the eyeballs of modern science. All these people do is parrot one idiot before them. And no invention, no creativity, nothing is discovered new unless you start to think outside of the box and you stop kissing the ass of the people before you that didn't know anything and the people before them. The way this device works is the same way the photoelectric effect works. It was discovered that there's a certain threshold frequency of light that caused the buildup between the cathode and the anode of electrostatic buildup. Okay? Now, Einstein's explanation for that was 100% incorrect, but since I understand exactly what light is, and I understand that Mother Nature's a really simple gal, she only works in force and motion, inertia and acceleration, resistance, capacitance, permeability, and permittivity. Everything is force and motion, inertia and acceleration. The way this works, and the reason why the higher capacitance light towards the blue end of the spectrum, but a little further than the blue, towards the purple here, why this begins to spin up only. This is the low emission LED here. Why it only begins to spin up with the higher capacitance and never with the red or the green or even the blue, because this is low output, is because what is actually going on is that there is an electrostatic buildup and a discharge against the medium. It is no different than a magnetic repulsion. It is a force repulsion against inertia. The reason that black vein, obviously the white light is reflecting. Doesn't matter what frequency the light is, obviously. The white light works the same thing with a flashlight. You bring it towards the white end of the vein, it'll stop. You point it towards the black end.
Okay, so that's an interesting. So
how can you oppose against inertia? Doesn't make any sense at all.
Yeah, so that's an interesting thing because there is an easy way to debunk this, right? Very easy to debunk what Ken Wheeler is saying, and that's with the thermal weight. So here you'd expect two different things. Now, obviously, in both instances, you expect to see more push with higher light. However, in Ken Wheeler's thing, you don't expect to see anything if you heat up the glass. If you heat up the glass, right, then you're going to see something with the radiometer. But in Ken Wheeler's version, if you heat up the glass, then you shouldn't see anything because, that's not electrical discharge. However, in the thermal explanation, if you heat up the glass, then you will see the thing move, and that's exactly what you see. Now, you can't heat up the entire glass. You've got to heat up a particular point of the glass, and then it will move.
Yeah. Okay. So my understanding of what he's saying there now is that so the photoelectric effect basically says that if you shine, it means that if you shine energy onto a surface, eventually an electron will be emitted. But what it says though is that in theory, like if you are you boiling up a pot or something like that, if you boil it up on a low heat, eventually it'll boil. Like it'll take longer, but if you boil it up on a high heat, it'll boil quickly. In this case, the pot boiling is the electron being emitted. So what they found in the photoelectric effect was that there's a threshold below which the pot won't boil. So you could be putting heat into the pot forever, basically, and it'll never boil. Or in this case, you can put a certain wavelength of light against the material, and it'll never emit an electron. But then once you get up to, but then there's like a discontinuity beyond which the electron will start being emitted. Or in this case, it's the same thing as this radiometer thing. It's like you have there's like a distinct threshold. Below this threshold, nothing happens. Above this threshold, something happens. And what he's basically saying is that this magnetism being a force, like I think below a certain frequency, that force isn't enough to move it. And then when you go beyond a certain frequency, there's now enough force in the magnetism of the thing to actually push it. At least that's my understanding of it.
Yeah, that seems to be what he's saying. Except that does ignore the fact that you can move it with heat. Yeah,
that's assuming that the heat thing doesn't exist. So we're going back to the original kind of incorrect, as Wikipedia describes it, explanation.
Ken Wheeler's explanation does seem to be different to the Wikipedia incorrect explanation, though, because the incorrect theory here says Crookes incorrectly suggested that the force was due to the pressure of light. His theory was originally supported by James Clerk Maxwell, who predicted this force. This explanation is still often seen in leaflets packaged with this device. The first experiment to test this theory was done by Arthur Schuster in 1876, who observed that there was a force on the glass bulb of the Crookes radiometer that was in the opposite direction to the rotation of the vanes. This showed that the force turning the vanes was generated inside the radiometer. If light pressure was the cause of rotation, then the better the vacuum the bulb, the less air resistant to movement, and the faster the vanes should spin. In Ken Wheeler's one, in his defense, it does actually account for the partial vacuum, because for it being a partial vacuum and not a full vacuum, because if in Ken Wheeler's one, if it was a full vacuum, then his wouldn't be able to move either, because he said that it presses against the medium in the presses against the medium to create thrust, which is somewhat similar to the thermodynamic explanation, but it's not the exact same thing. Two different mechanisms to create the same effect under the same circumstances.
What he's saying is that you got to think of the light as such as a little bubble of magnetism that comes up against this dielectric plane, and they don't like each other, so there's a reaction when the two hit. And what he's saying is that there needs to be a certain amount of magnetism in the light before it overcomes the inertia of the vane. So it needs to have a certain amount, and nothing will happen unless there's that much magnetism in it to overcome the inertia.
But again, his explanation is still wrong, because it just ignores the fact that you can essentially heat up or cool down the glass, and it will have an effect on the movement. And yeah. Anyway, I do have to get to this thing here. I don't know how well this aligns or goes against what Ken says. I do not know if I'll disagree or agree with this, so we're just going to see what Oh, Jesus Christ! That's 59 minutes. Okay, let's turn the playback speed up to 1.75.
Yeah.
Let's try and speed run as much of this as we can.
Sorry for the delay. For those who've actually followed me, my name's Nigel. I'm 50-something, at the best guess. I used to be a sailor. Then, I had the name of Hans. There you go. That's me. That's my name at the bottom. Now, I served for 22 years in the Royal Navy. There's the proof. There's only ever one of these. That's the proof. Thank you for all the years I've been in the Navy. That, what I'm about to tell you, will either make you cry or make you angry. Take your choice. 35 years ago, I made a video. And on the side of the video, on the side of the AVO multimeter, it had my name like that. It was clearly displayed as I was doing everything. So there's only one AVO.
He needs to get to the point.
There's only one of me. There's only one.
Yeah, he's as bad as Ken is and as bad as we are. Although,
Worse than Ken. I made Dirk Dawkins him. I made Sever meet him.
yeah, wait, who did you mention?
Dirk Dawkins.
Oh, I want to debate that guy.
I'm probably gonna debate that guy too eventually, but I'm gonna make some political ballpark cartoons first to make fun of him, just to give him some incentive.
Yeah, I want to debate that guy because, I mean, if Darth Dawkins just so happens to come across me at any point, just let him know that I'm willing to debate him because I kind of understand his explanations. Like, I understand what it boils down to at least. And I know that his explanations are just incorrect. Yeah, Darth Dawkins is just a script, Andrew L. Anyway.
And if we can't find him, we'll just debate each other in the style of Darth Dawkins.
Oh yeah, exactly. That's a great way to go about things. Anyway.
Trundling around claiming to be me is wrong. Now this is what I've done in the video. It caused a death of at least one man that I know of. That death, although claimed accidental, was most likely to have been murder by the Royal Navy. I said to a group of very, very high-level people, what's 1 and 1? 1 plus 1.
Guys, I'm gonna hit the road.
Everybody like yourself turn around.
Okay, take care.
Yeah, thanks.
It's a good conversation.
Yeah, mate. Nice meeting you. Very
Yeah,
good.
enjoyed it,
Like
guys.
stuff.
Enjoyed it.
Okay, so it says 1 plus... So obviously he's going to try and justify 1 plus 1 equaling 1. Let's see what...
Oh, it's going to be 2. I said, no, it's not. You've got it wrong. And I said, why? I said, because of this. As you can see, there's 2 magnets here. How many norths and how many souths?
You can redefine plus.
In the room, on the board, a magnet with a north and a south. And I said, you have 1 north, you have 1 south, but you have 1 magnet. And I went, yeah, so what? What's the crazy about that?
Just make plus an identity operator.
You've still only got 1 south, 1 north, and 1 magnet. So 1 plus 1 equals 1. And even with inside 1 magnet, you have 1 plus 1 equals 1. And if you keep going all the way down to the atomic structure, right the way down to hydrogen, you end up with 1 neutron, 1 proton equals 1 atom. And they went...
Okay, so... That seems to be his Okay. Now... I am not sure about... There's a few things that I do not know, but like... Because I do know that if you join 2 magnets together, the total amount of magnet that you have is, 1. The issue here... So, when you add 2 magnets together, firstly you have a different volume of magnets, right? You may have 1 magnet, but... you have a different amount of magnet there. Now, when it comes to the north and south, if you combine 2 magnets, I think that the north and south have different separations. Am I right? Or am I wrong?
Yeah.
Yeah. So the 2 magnets joined together does have a difference, right? You can't just add 2 magnets and you have the same thing. You have something different, and that's really the point of the point of this thing now. I am wondering, is there a different strength when you combine two magnets?
Well, yeah. Did you remember doing the magnets with the iron filings at school? And you see the field off the magnets, and if you break it in half, you get the two smaller ones. It's the way the field lines up around the actual, what do you call it, the magnetic material. So, yeah, breaking it in half, it becomes two. He actually got down to a proton-neutron. So his hydrogen atoms don't have electrons. Is that correct? Because the electron's a negatively charged particle and the proton's a positive, and the neutron is the neutral. So he's a salesman. Yeah, this is snake oil for sure. But, yeah. It's the magnetic field we're talking about, not so much the actual magnet itself, but I can't, like the planet with gravity.
Yeah, I suppose, hold on, let me look for a hammer. I'm going to... I have pliers. Oh, here's my hammer. All right. Here we go, hammer and magnet. You're going to hear a bit of a bang. Warning to anyone with headphones, I guess. Oh, shit.
You hope you've got safety glasses on.
That didn't...
Here we are, rebuilding the kitchen.
Oh, Jesus Christ.
Is he dead? I think he's dead.
Hold on, that might have not been a good idea to hit the magnet. That might not have been a good idea to hit the magnet with a steel hammer. Because I just saw a spark come off this magnet. Okay, let's... Hopefully I don't burn the house down. Okay. Okay, I've broken it enough. All right.
So, well, if you get two magnets and stick them together, south to south, north to north, they're going to push apart. But if you turn them around, they'll stick. I can't remember what happens to the magnetic field then. You know, if you've got two of the identical size. But you've got to have them opposed in order to attract to each other.
Yeah, all right. So, here we go. And let me just clean this off. And, yeah. Let me just clean off this magnet a bit. Oh, jeez. This came back to the magnet. Very attractive magnet here.
Just a bit of a side note here, Planner. Look where he's paused it. It looks like he's kind of... That's not a very flattering position you've got him in there with the big mouth open. It looks like he's ready for a gobby.
Okay, I am currently looking...
Yeah, screenshot that.
I'm currently looking... That could be the next emoji. Alright, so I'm currently looking at... Yeah, this makes a lot of sense. I'm currently looking at the the bits that are broken off this magnet, right? Don't worry about me breaking a magnet. This magnet was broken beforehand, so we've got bits broken off this magnet, and yeah, this is not attracting the bits of the magnet. But if I were to move this bit now, it's really hard to... Hold on. Let me actually... Hold on, I'm gonna just bring up... Let me just move some things around. Alrighty. So if I move my camera... Ignore any mess on my desk and the money that you see on my desk. Don't try and steal it from me, please. So if I go to camera, right, and I bring my camera down to here, right, we can see here, we can see here we've got a magnet right here, right? This is like the bits that are broken off. Now if I move this bit of magnet close, right, we do not see any attraction whatsoever. However, let's move that away. And instead, I'm going to take this magnet and move it to the same distance. Oh, either I'm nowhere close, and it's still... Like, here's the magnet, right? I'm not even as close as I was before, and it's already making a difference. And I move it a little bit closer. Oh, things... This one... Okay, that one's being a little bit stubborn. Yeah, I just touch it and it just flies towards it. Whereas the other thing did not attract it at all. That means what we can conclude from that is that you have, it's really down. Like if you have a whole lot of magnetic material, this is not a perfect thing. Like I could probably, if I were to like try and break it in half, I don't think I'm gonna. No, I'm not going to be able to break it in half. And I don't want to hit it with a hammer anymore because I did see it spark. But essentially... Oh, let's bring that back. Essentially, yeah, it's down to how much magnetic material as to the strength of the magnet.
So mass and magnetic strength are related.
Yes, I'd say so. Because if you have a little bit of magnetic material, then it's going to produce a small magnetic field. A lot of magnetic material will produce a larger magnetic field. So if you stick two magnets together, you should be producing a greater magnetic field. What I could do is I'm just a little bit worried about if I were to get a magnet and try and break it into half and then try and test all this kind of stuff, because I'm a little bit worried here that I'd burn the house down by hitting it with a hammer. I saw a spark, right, fly off. It wasn't a spark that flew off it. It was more of I saw it light up, and I was like, "Oh, geez, that looks like that." It was like it looked a little bit red, and didn't fly off. It was just stayed there. But I was like, "Oh, geez, that doesn't look good." But when I hit it again, it didn't. Yeah, the iron filings do show the difference of the magnetic field. So more magnetic material. Get some smaller magnets. Yeah, I should probably get some small magnets. I should probably get... What I'd like to do, right? I'd really like to do some... I just read that magnet dust is flammable. Oh, okay, that would explain why this lit up. When I hit it with my hammer.
Yeah, Planner, look, we did get taught at trade school that one of the ways to make a permanent magnet lose its magnetism is to hit it. So, anyway.
Yeah, that makes a lot of sense, yeah. Maybe I shouldn't be hitting my magnets with a hammer. Oh, jeez.
And I found a bunch of binary logical operators he could redefine +2 to make that 1 + 1 make sense.
Yeah, now that is one thing that I will admit that I was initially wrong about. So when it comes, because this is probably something, this is probably to do with a video, may not be to do with a video, but 1 + 1 can equal 1 if you are using Boolean logic, because if you define 1 as being true, 0 as being false, well, true and true, if two things are true, well, then you got true. Now, 1 + 0, that would be true, 0 + 0 is false. I think there'd be 1 or, so... Yeah, that would be the or, right? So 1 and 1 would be 1 or 1. 1 and 1 would be true as well. 1 and 0 would be false. And then there'd be exclusive or, so that would be 1 or 0, but not both. That would be 1 or 1 would be, or we'll say X or 1 X or 1 would be 0, because exclusive or would mean that they can't both be true. You can get strip magnets at a hardware. Yeah, maybe I need to go to Mitre 10 and see if they have magnets there.
Actually, Platter, I just want to jump in. Firstly, the Magnetic Commission rang up and said that you've been demoted to fridge magnets only now, so you're not allowed to hammer them. And the other one is, you know those letters that you put on your fridge? You know the little kids ones? They've got like a little 2-centimetre magnet in them. If you go and get 2 plastic letters like the 2 8s, if you stick them together, they'll repel. But if you turn it round, because, the 8's a bit smaller at the top, turn it round, they'll stick to each other. But I've got a feeling the magnetic field inverts 90 degrees or something really weird like that. If you get them out of a starter carcass, you've got 2 magnets that are permanent magnets inside a starter motor, and the bit inside gets charged up, hence the spinny. And they don't stick to each other. They'll hover if you can sort of hold them in place, but if you turn it around, they stick. So I think the field inverts 90 degrees, but I can't remember. It's kind of too long since I was playing around with that shit.
Anyway. I like, so here's what I like. I like superconductors, right? Or type 2 superconductors specifically. Because they do some weird shit, man. Essentially, you can place it above a neodymium magnet rail, and you can and it will just sit above it. I'm not sure if they... I do not... actually, I do have some speakers, but I'm not sure if they're old speakers or not. They probably do have a magnet in them. I do know that this microphone will have a couple of magnets in it because it is a what's the... condenser mic. This is a condenser mic, not a... what's the other one? Does anyone...
condenser mic and just a... Oh, shit, what a diaphragm mic.
Yeah, I think it's diaphragm. Yeah.
Well, it's a magnetic strip one too, the old 50s style ones.
Isn't that a ribbon mic?
Kind of ribbon mic. That's a ribbon magnetic strip, isn't it? I think, or something.
Yeah, I do know that. Yeah, I do know that with ribbon mics, essentially, you should not provide them with phantom power. Firstly,
that kind of makes a bit of sense there.
Firstly, I should start off by saying that when it comes to condenser mics, you need to provide them with phantom power. When it comes to the other types, hold on, let me just make sure it's diaphragm mics, because otherwise I'm going to look silly considering I did an audio course. Dynamic microphones.
Yes, dynamic vocal mic, Shure SM58. Yes, of course.
Yeah. So the dynamic ones, you do not need to provide with phantom power. Julian Weinhardt says you're thinking of dynamic. You do not need to provide them with phantom power because they, you speak into them. They, everything works. I'm not sure. I can't remember exactly why, but I do know that
because
condenser mics.
The voice pressure pushing down on the diaphragm provides that little movement. And in fact, a speaker is the same principle as a microphone. They're just opposite ends of the amplifier. So you can actually use a little speaker, like a phone speaker, as a microphone. It's crude, but it can work. So there you go. There's a bit of a...
Now, what I learned is that you should not provide... I think ribbon microphones are a type of dynamic microphone, and
they are.
You should not provide phantom power to them because... And now you can provide phantom power to them. However, the reason why you shouldn't provide phantom power is because you do run the risk of bursting them if you provide them with phantom power. But it's not because you're providing them with phantom power. It's because of if you're using a patch board. If you're using a patch board, and a lot of people do use patch boards, and you're providing phantom power to them, you pull that thing out, and suddenly it's not grounded or something like that, you burst the mic. If you're just using XLRs, and you provide phantom power through the XLR, not using a patch board, or at least don't pull out all the patches and all that, then you should be able to get away with it. However, it's just best not to run that risk. Your dynamic mics generally are fine with phantom power, but ribbon mics are not good with phantom power.
We actually taped off the phantom power buttons on our mixer at the pub because those dickheads that just flick all the switches and they're actually flicking on phantom power. Mixing desks generally have a phantom power provision if they're a new one.
Yeah.
Yeah. I've just got one to throw at you, though. An electric guitar pickup. There you go, dude. That's a beautiful source of magnetism because the strings are the earth, the pickup is the positive side, and the beauty of it is the Strat has got a single pole, but when you put the two poles together and wire them in series, like your batteries, positive to negative, when you wire two single poles in series, they humbuck their noise cancellation. Gibson were very clever when they made the humbucking pickup because it's zero noise until you pluck the string. That's why Les Pauls don't go nyeh when you have lots of effects on them. But a Strat does. So if you've got an old pickup lying around, dude, there's some fun magnetism because they're little tubey ones. So,
yeah, I actually noticed, because... Give me a second.
You got an electric guitar there? Don't go pulling it apart. It's a perfectly fine guitar. We're going to do it when you've got an old pickup. You can break it up. We've already seen you with that. Enough hammering today. Will it blend? What's the plan of hammering today? Hammer Walk is your new name.
All right, so let's get the hammer again.
Oh, no.
Here we go.
This ain't going to end well.
I'm going to use the other side that doesn't have, the bits of magnetic bits on it, because they are not coming... Oh, some of them came off, but whenever I try and get them off, they still stick because magnetism to iron doesn't tend to. Anyway, if I go here, yeah, this is sticking to the magnetic pickup. This hammer is not magnetic. I can prove that by this doesn't stick to it. If I grab my magnet, or actually, if I do here, and here we go, it's sticking to it. So yeah, it's sticking to the pickups. So that proves that pickups are magnetic.
Yes, and they're the positive side of the flow. So they actually go microphonic when they're really loud. When they're fucked, they're actually microphonic as well. They feed back. So a pickup is actually a very badly designed microphone when you think about it. That's cool. There's a bit of a science class for you music kids out there.
Yeah.
Stay in school and don't get in a band, okay? It's not a good idea.
I mean, yeah, I didn't get in a band. I learned music, though, or at least a part of it.
You can never learn all of it.
Yeah, actually, Flamio has a good point, and we'll see. If there's a particular time that they wanted us that, because if I go back to the, I don't know, so it's easier to just, let's reload this. If I reload the super chat stuff, and yeah, Trace D was because they sent 2 super chats in saying watch the video that I sent, and I've watched part of it. If his whole argument is based on that thing, then his premise is incorrect. We can watch a little bit more if you want.
Oh,
yeah, let's watch some more. But if we try to sit here to watch this 1 hour video, we'll be here for 8 hours.
True.
But we are digressing in good directions, though. That's fun.
Yeah. When it comes to these streams, they are generally more of a... They're generally more of a off-the-cuff thing, which doesn't necessarily have a particular direction that it's going in. Whereas when it comes to my videos, they're generally far more well thought out. And, I try and stay on topic. Sometimes I go off on a tangent, though.
Oh, God. Hey, Bugger33, mate, we can take a 10-minute video with Quiddy, Zoomy, and U-Platter. And as you know, Donna Dapper, we can take a 10-minute out to 2 hours. So, yeah, it's easy work. Okay, but let's not do that. Hey, Nimrod, how are ya? Sorry, I just saw Nimrod turn up.
Okay, here we go.
Oh. What can you do with that? I said, absolutely loads. That's why I'm here. So not only did I trash the principle of Euclidean mathematics based on a magnet, I then went on to scare them. I said, you always perceive that infinity looks like that. Whereas if you look at infinity very, very closely, it's actually 2 circles. When you look at one circle, it's 360 degrees. Plus 360 degrees means infinity is 720 degrees.
The fuck? No, that's not how anything works.
He's a numerology professor, apparently.
He's a what? Numerology professor?
Yeah, numerology.
Isn't numerology that thing that says that you're going to die based off like numbers or some shit?
Yes, and then the other BS you can make with numbers, drawings, and misinterpreting them.
Yeah.
Yeah, this actually sounds like I might be an interesting thing to go ahead and debunk. Just like I'll probably not go through the whole thing, but I'll probably just go through bits and pieces and be like, oh yeah, this is funny. Yeah, that's not how any of that works. Like, just because something looks like two circles does not mean that it's 720 degrees. It's like me saying that 8 is two circles, and therefore it's 720 degrees. No, that 8 is 8. It's different.
And you can do that in numerology, and people will pretend it makes sense.
Yeah, numerology is holo bunk. Yeah, not off to a good start. With 3 minutes and 54 seconds in, it's already not off to a good start. Anyway.
Yeah, so what? So, well, it's not. You got it wrong. Again. Because everything resides around a magnet, a lodestone. They've been here an awful lot longer than us humans. So when you take a magnetic body like so, and you have a north, and you have a south, you think that's it. Well, it's not. It goes from there, and then goes around the back, goes over itself, and goes there. And the other one goes the other way. It goes from there, it goes around the back, around the south, and goes there. So you end up with a loop there, a loop there, a loop there, a loop there. But these two loops are actually one of the same. So you end up with a value here, which is 360 degrees. A value here, which is 360 degrees. A value here, which is 360, and 360. So you have 1,470 degrees.
Ken Wheeler drew that before.
Yeah, I've seen that like, it looks like something that Ken Wheeler has drawn. It's like
and it's what, yeah. Cool Hard Logic's pulled it apart too. Who's that other one? That Spirit Science guy. He did the same crap with patterns. Hey, I've got one though. 1 and 1 is 11. So using that 1 and 1's 11 theory, I've just got a huge bank account. Wow, I'm going to buy both.
Yeah. Like, here's the thing, right? If 1 and 1 is 11, right, here's what I'm going to do. I'm going to take off 9. We're end with 2, right? And...
No. I'm not giving you 9. Fuck you. No, it's mine. It's my 11.
No,
it's your own.
Don't worry. I'll give you back more 11. Because if we take off 9, set that 9 aside, right? And then we're left with 2. We can split 2 apart, and then we've got 2 1s, and we can put them back together again, and we've got 11. But not only do we have 11, we also have 9.
Oh, winner! Yay, chicken dinner. Oh, you got a boat.
And with that 9, and with that 9, we can take off 7, right? And we can, if we can take off 7, we're left with 2, right? We can split that apart, and we've got 11. But then if we add 11 and 11, we've got 1,111. Oh, and we've got more in the 9.
We've got
7. We can take off 5. And, we're left with 2. We split 2 apart, and we've got 11 again. And we add that, we've got 111,111. We're really ranking. We're really racking up the numbers in the bank account here.
Nobel Prize incoming. Oh, mate, we've nailed it. Lil needs a peer review now, and we've got the Nobel Prize, according to Kent Wheeler. Lovely. And we can pay them with the money we make from the fucking bank account shit. This is a winner. I wonder if anyone listened and heard that in the chat. Shh, keep it our secret, all right? Secret to free money. Hey, there's 22 watching the chat. We can split those 2 off into 2 11s as well. Oh, beautiful. This is... Oh, dude. Fuck. Hey, it's hookers and blow from here on.
Yeah, I mean, I've got some super chats today. I wonder how... I mean, hell, super chats... what have I gotten from super chats? It's... Oh, wrong things... There we go. So we've got $25 US, right? That's basically if we do that, that's how many 11s? That's divided by 2. Well, essentially we've got 25 ones, so that's a 1 followed by 24 ones. So that's a lot. That's like trillions, more than trillions of dollars. I don't even know how much money that is. Yeah, and we'll get a visit from the IRS. Or in New Zealand, it's IRD. But not if we have it offshore in an offshore bank account. We might need to do that.
You are the offshore bank account.
Well, the offshore bank, depending what offshore bank account we're talking about.
You're in New Zealand. We're gonna put in your account.
Yeah,
or the globalists gonna hide.
But I just ordered the Segway off eBay and a new dirt bike. Oh, dude, I'm wrapped now. I'm so happy. Today's been a winner.
I do know that New Zealand is a tax haven, I think, because of certain like tax loopholes. Although, to be fair, when it comes, I have made use of some of these tax loopholes. Like I can write, there's like a lot that you can write off when it comes to as expenses. So I've made use of them. That's how I've been able to actually afford my rent, because I'm able to write off a whole lot as just tax write-offs, and like I've got everything documented. So if IRD comes with knocking, I was like, oh yeah, here's everything here, all the tax deductible stuff that I've mentioned, and yeah, there's a paper trail everywhere. So yep, I can write off a whole lot on tax. So yeah, hopefully they don't find anything wrong with that if they do come a knocking. Or better yet, hopefully they don't come a knocking, because that feels like it would be I feel like that would be a little bit stressful. Like, okay, so here's this, oh yeah, and this is the bank record, all that kind of stuff. It's be annoying to have to be like, oh yeah, things here. Alright, but anyway.
Okay, let's get back to what's his name, Silverhead Snake Oil Salesman.
Yeah.
He's so significant, I can't even remember his name.
Dr. Cheese, I believe.
Q says, IRD, open up. I like how there's a couple of Qs. We've got what's the other Q that we had earlier? Can we go up and find them? Q continuum, and we've got Q. Just anyway.
Are these Star Trek Qs that are just annoying pests, or are these QAnons that are just annoying pests? I'm not quite sure.
QAnons.
No, they're actually
Q nonsense.
They're actually Star Trek Qs. More likely.
Cool. Okay.
Tree Potato says, right. Oh no, not this guy. Okay, if you know more about this guy, please tell me, because
I'm not sure if he means me or the guy in the video. It's always a bit ahead of this.
Yes.
Why not both?
Yeah, we can have both.
Actually, I should probably turn on the thing here so that people can see. There we go.
The problem with that is when you overlay it on the earthbound model of what you humans think you have, you think you've got that, which equals 720, and I've just proven there's that, which is actually 2 times that, or twice infinity. Oops. That did upset an awful lot of physicists and mathematicians in the room.
I'm pretty sure the physicists were going, what the fuck are you even talking about? I'm pretty sure that if I were to get AB Science in here, but he's probably asleep, he'd be like, the fuck you on about? No, this is just, like, you've just said that this is a thing, and now we've got 1440.
And mathematicians would just want to figure out a way to pervert math to make it make sense. That's what they do. Matt Parker is slobbering over this already.
Maybe. Anyway.
There was only one who actually stood by and nodded and giggled in the background, and it was a chap called Lieutenant Commander Ian St. John Stevens, about the brightest man I ever met. He used to be my professor. I was his protege. He used to poke me with all sorts of stuff. So after I showed them that, they said, well, you can't screw around with infinity. You're not allowed to, because everything's based on infinity. I said, absolute rubbish. If we take a dot, if you claim that dot as 0, we can go in a direction for infinity, like so. But it also means we can go the other way for infinity. And therefore, for infinity to exist, it needs to be 2 times infinity. That's what you said in the moment. Furthermore...
What about when you go up and down? What if you go back and forth? So now we've not only got infinity and infinity, we've got 6 times infinity, because there's 6 directions that you can go, and that's ignoring the fact that in 3-dimensional space you can go in a combination of one of those directions. So yeah, but here's the thing: these infinities cancel out, because if you go one direction in infinity, then you're going in positive infinity, and the other direction is negative infinity. So these cancel out, and they equal 0.
But
this is simple. All you need is imaginary infinity and negative imaginary infinity to represent the up and down.
Hang on, guys. If the schoolyard has taught us anything, and it has, infinity plus 1 trumps everything. We knew that when we were 9. Done. I'll get infinity plus 1 on this guy. He's not thinking it through.
But even then, this is probably something that Ken Wheeler would probably say. So I'm not sure how much I'm going to stick by this, but for the concept of values to exist between infinity and the 0 point, is you need to have something between 0 and you need to have 2 things for any concept of distance to even exist. Because if you don't have 2 things there, then distance just does not exist even as a concept.
Correct. I would say that too.
Yeah. So if I have a ball, right, and there's nothing apart from that ball that exists in the universe, then distance just does not exist, because, I suppose you could measure the size of that ball, that's the only way, but, if you have a single point, point would be better, and you've got no other points in that universe, well, then distance between those points...
I do pose the question.
Nothing.
What I love throwing at religiotards is, why does God have legs? Because if you're omnipresent, you don't need legs. You're everywhere. Why would you fucking walk? Why would you even waste the time having legs? You get a sore toe and...
It's simple. Yeah. Yahweh is lying about his omnipresence and omnipotence.
Okay.
True.
All right.
And, the thing is, some people may say, well, how do you know he has legs?
Bible says so.
Yep, the Bible.
He made us in his image.
Exactly. Yeah. That's exactly what I was getting at. Yeah.
Yeah.
So we know God has legs, so why does God need legs, is my question. Well, that's actually Boomer's question, but, I'm stealing that.
Yeah, it was. You may steal it.
I actually have a video idea that I don't know how to expand into a decent length video, and that's
also
a question.
Second edition on Planet Walk After Dark is, why does God have a peenie and where does he put it? On Planet Walk After Dark, mate. Be back for that one.
That is a good stuff. That is a good question.
Okay, yeah.
But my thing is, so a lot of Christians say that, how do you know that the Big Bang happened? Were you there, right? And you want to know my answer? It's a very...
No?
My answer is yes, I was there.
Yeah.
And then they would say, no, you weren't. And I would say, how do you know? You weren't there. I would know that you weren't there because I was there. You weren't there. Impeccable logic. They cannot refute it.
Well, we were there. Well, we were actually all were there at technically, what do you call it, Big Bang plus 2 seconds, because once all that had happened, the water molecules that make us up were there. So we were at the Big Bang, or every fucking one of us. Even Nathan fucking Thompson was there. Damn. Oh, we're in the... Oh, no, we're in the same singularity. Oh, that's not going to wash off. Oh, Platter, we just solved the universe, and now you fucked it up for me. Oh.
Yes, allegedly Dave was drinking himself.
Oh.
But that would still be my logic. I'd say, yeah, I was there, and I know that you weren't. And it's like, and if they say, no, you weren't, I'd say, how do you know? Were you there? No, I know you weren't there because I was there.
I love that. I'm going to steal that. You can have the guy that has legs, and I'll steal the I was at the Big Bang. Yeah, because I didn't see you. Cool. Okay, that's a fair swap. I'll just organise the paperwork. Okay, it's done.
And I'll take them both because I'm rum-pilled.
Okay. Hey.
Okay. I'm going to keep mine as well, though. But I'm just going to I'm going to steal it. We'll duplicate it with the 1 + 1 = 11 glitch. That's how we're duplicating.
The new infinity is 1 + 1. Yeah, we've done it. Okay. Wow.
Yeah. Anyway, let's see what he's going to ramble on about.
Or if you can go that way, 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 you can go that way.
Oh, he mentioned it, so you can go up and down. So, he's infinity pilled.
You could say it's a field.
Yeah.
Here's a given length in space, and when you do that, you get an arc. Like that. When you do it again, when you do it again, when you do it again, that is pi. Therefore, because that curve...
Actually, no, only half of that is pi. The full thing...
Yeah, that's tau, not pi.
Yeah. Maybe he needs to go back to maths class.
is longer than a straight line, like that. It means...
Perfect time for a brilliant sponsorship drop. Do you have a brilliant sponsorship?
Wait, who?
Brilliant.org. Do you have a Brilliant.org sponsorship? It's a good time to sell that math class so you, Professor Nigel Cheese can go back and relearn the difference between pi and tau.
Yeah, if I got a sponsorship from Brilliant, I'd absolutely take it. Because I actually found out about Brilliant through an ad, and I've used it a little bit, but I'd absolutely take a Brilliant sponsorship because I do like what they do. Like, the sponsorships that I would not take, especially seeing as I'm competing with Raid Shadow Legends. If Raid ever reaches out to me, I'm not taking that sponsorship no matter what. Because that's a competing product. Why would I take why would I take sponsorship from a competing product? Unless it's a Final Fantasy game decides to reach out and sponsor me, in which case, okay, fair enough. I do play Final Fantasy games, so I would take that sponsorship.
Cross promotions, why?
Oh yeah, that would be something that would be interesting. Doing cross promotion. My actual issue with Raid isn't that it's a competing product. Because it is a mobile game, and like I am not dipping into the mobile market anytime soon. My actual problem with Raid is that it's just a bad game, and I don't like. I do not like mobile games in general. I think if I remember correctly, it's basically a game where it tries to shove as many microtransactions in your face, and I'm not a big fan of that. I prefer games to just be made and then not shove microtransactions in your face.
Yeah, pay to win.
Yeah, I'm not a big fan of pay to win, even though I have played some pay to win games like Magic the Gathering before. But I mean, yeah, that's...
We all played Magic Gathering or Yu-Gi-Oh! We need to make a game where it's the same card battle game, but you just have all the cards. That way we can balance it properly.
I mean, that's what that's what poker is, right?
Yeah, you know what? Sure, we'll go with that.
Yeah. Yeah. Anyway, well, see.
Infinity. Oops.
Wait, what? Hold on.
Pi. Therefore, because that curve is longer than a straight line, like that, it means that pi is greater than infinity.
No, because that straight line there is not infinity. That is a straight line between... That is what we call a chord. I think it's a chord.
Yeah, it's a chord.
Yeah. And a chord has a finite length. An infinite... If that line was infinite, then it would have an infinite length. But you'd find that it's longer than the circle because a circle basically does not have an infinite length.
Unless he's assuming a unit circle.
Yeah, because eventually, if you plot a point on a circle, right, eventually you get back to that same point.
Yeah, unless he's assuming a unit circle and he's demonstrating hyperbolic geometry on it, then it is an infinite line.
So, Professor Nigel Cheese. Wait, hold on. Let me see if there's anything. Let me. I want to see. Let me see if I can find anything about this guy.
Hey, where you paused him now is even less flattering than where you had him before. Now you got him in a big kiss. Oh my god.
Hold on. Let me see. Nigel Cheese. Yeah, I'm not finding anything. Oh, here we go. Confident man thinks he can... I found something about him on... Oh! Oh, lovely. Lovely. It's the video that we're watching. Confident man thinks he can disprove physics. I give you Professor Nigel Cheese hands. TLDR, Professor thinks he's smarter than Einstein and tries to prove it using bad maths and a couple of bar magnets. At various points during the video, he claims he upset the status quo by revealing these secrets to a group of military superiors, and they tried to bury the truth.
I can see it right now. Professor Nigel Cheese plays Baldi's Basics.
Oh! Hold on! Oh, overlapping things. I saw 5 minutes of Simon Dan's video on this guy. That was all I could... Hold on. Hold on. I did not... We're going... Hold on. This... Oh, no, that's not the Clown Voice one. Let's go... Simon Dan... Why does Matt Dillahunty come up?
Because they're the same person.
Oh, no, because he had Matt Dillahunty on his podcast. And
is he the Atheist Experience with Tracy Harris? Is that Matt Dillahunty?
Yes.
Yeah.
He's pretty switched on. Actually, I wouldn't want to get him in a debate. He's fucking good.
So, Nigel Cheese, not Richard Cheese. Richard Cheese is good. Nigel Cheese. Let me see.
Dillahunty's good, but I think I can trip him up.
Potentially. Let me search Nigel. Okay, I want... Let me search Cheese. And it's flat earth stuff. Hopefully Nigel Cheese is not a flat earther. Oh, yeah, I found it. This video here.
You know,
this video here by it's actually a video that I hadn't seen from. That's a good joke. I only recently found out that Albert Einstein was a real person. All this time I thought he was only a theoretical physicist.
Oh, I got stolen.
Yeah, so
at 2 degrees.
Let me just mute the ad.
Blessed are the cheesemakers. Anyway, sorry.
Yeah, so if we go to here.
I have an extension with that.
Yeah, it's the exact same video as well. So yeah, whenever hell with it, I'm still going to debunk this guy in my own video because why not?
No one watches Simon Dan anyways.
Yeah.
I mean, hell, I'm debunking a video that I've already seen from Creaky Blinder, so I'm also. Hold on. I realised something.
Imagine being so confident in your abilities that you claim that you can debunk Einstein and Newton. Imagine having the absolute cojones to say Eve each day. One of the things I love about it is called The Journey. They're behaviour programs designed specifically to help you...
Dan, no! Dan! Dan, I've got to... Dan, I'm calling you out right now, right? I don't know if you're even watching. You should have taken a brilliant sponsorship for this video. You hit the perfect... Like, I'm sure you've taken a brilliant sponsorship before, Dan. That would have been the perfect opportunity to take a brilliant sponsorship. If anyone from Brilliant is watching, give me the opportunity. I probably won't have the opportunity to have any sponsorship, but if I'm going to do a sponsorship, and if there's a sponsorship that I'm going to do on the video, I'm going to do a Brilliant sponsorship. But any other sponsorship, no.
Not even a Wolfram school if they want to sponsor?
Maybe. Like, it would have to be a relevant sponsorship, but this doesn't seem too relevant to the video. Because, like, the thing with sponsorships is most people do skip over the sponsored section of the video. There are times when I do watch the sponsorship, like Ryan George. Often I will skip over it, but then I realize that, hold on, wait, no, these sponsored segments are actually funny and worth watching. With sponsorships, yeah, most people skip over them, even if you do have a nice segue. Sometimes I will watch the sponsored segment, but yeah. Dan, why didn't you take a Brilliant sponsorship for this? Why?
Tell you what, Planner, I've got one for you, mate. If you say to the Brilliant people, we could organise full access to Karen rights, you know that beautiful blonde friend offsider of yours, Karen, I'm sure the people at Brilliant might just give you a second look. If Karen's on the table, mate, we all love Karen.
I'd actually probably...
Big hello to Karen, by the way.
I'd actually probably try and make the sponsorship a funny section. Maybe bring in Karen.
If you could, mate, can you send her just a message? Can you send more pics, please? That's all. She'll know what it means. It's okay.
Yeah.
I watch a product placement, but I do not watch the just break up the content ads because I have an extension for that.
Yeah. I mean, with content, like ads embedded in the content, there's no real way to avoid... Like, that's why a lot of advertisers go with content ads, because with content ads, it's something that, it supports the creators, obviously, but it also is... You can't prevent that with ad block, right? The only way to prevent it with ad block is to have, like, an artificial intelligence that analyzes the video and goes, well, this is a paid segment, so skip. Whereas when it comes to paid videos, when it comes to ads that play before a video, and that's potentially a way that YouTube could get around it by including the ads in the video stream, but then you wouldn't be able to have skip ads, or at least...
There's a funny one I saw on a video. It was, are you familiar with a thing called a Ridge wallet? It's like a little solid wallet. You put your credit cards in and a little bit of cash. It's like it looks cool. It's kind of high tech and hard, and you don't lose it. Anyway, it was in a thing on Panzer tanks. I'm a bit of a World War II buff. Anyway, it went through all the tanks and got to the medium size, and then puts in the Ridge wallet, and then goes to the next size tanks. And then all the people in the chat, I just said, "Oh, the Ridge wallet, one of the finest tanks of World War II," and it started. Everybody was quoting what the Ridge wallet was, and then people were commenting saying, "I went looking for that." That's really it's so funny the way they sneak the ads in. It's very cunning though, because we started doing jokes, and I realised later we're advertising Ridge wallet in the comment section. That is brilliant marketing. It actually really works. Make it a joke, people repeat it.
Yeah,
give them some break.
Yeah, that would be a thing to do. But yeah. Anyway, I think Mainframe did make a point. 4 hours, bring it home, guys. People have things to do. Yeah, I think it is about time to end up the stream. What do you guys think?
Oh, well, I've only been here for 2 hours, but yeah, that's a good idea. On your Mainframe, you hate us, obviously.
Yeah. And I will be making a video on Professor Nigel Cheese. When it comes out, that's a good question. Next video that I will be doing will be a video on Matt Powell. Maybe I might cover a lot more, and maybe I'll make a 1 hour video on Professor Nigel Cheese. Who knows?
But I got the screenshot, so you're ready.
Yeah. Both screenshots, you know, like he's doesn't have. Okay, now I am someone that does not have a photogenic face that often. He does not have a photogenic face either. You just take let's go Okay, that's not his face. Random point in the video. You know, like that is not a photogenic face. His face looks better in motion. There are some people that do have that ability to, whenever their face, if you take a snapshot of their face, it looks kind of weird. Like, but if you play their face, you know, it doesn't look as weird. You know? I can go to another point. Oh, jeez. We're seeing some weird... Okay, that's the most normal I've seen his face. Yeah, but anyway, we'll end this up. So leave a like and subscribe if you liked this stream. Leave a comment of what you'd like me to cover in future videos and streams. I probably won't do a stream on Monday. Instead, I'll probably try to pump out a video on Nigel Cheese, because that's going to probably be quite a long video. Hilarious, but long. Because I can tell you right now that it's just going to have... It's probably going to premiere, and people are just going to be constantly face palming the whole time. So fun times. So yeah. Anyway,
it'll be really short because there's no content in it, because it's not making any sense at all.
I mean, when people make less sense, that's more fun for me. The less sense people make, the more fun making the video is, because it's just something that. You know, they say things that are just weird, and it's like, that's just not how this works. Now, here's how you can try and make it work, but it still doesn't work because, you know, that line is a chord, not an infinite line. If it was an infinite line, then you'd have a point, but an infinite line would be longer than the whole length of a circle. And just more.
Speaking of infinite lines and infinite streams, I'm going to give Bunker 33, NASA Bunker 33, a quick plug. We're doing Guess the Product from the Amazon reviews on, Wednesday, 8 p.m. UTC. So if you check it out, don't forget to like and subscribe us guys at NASA Bunker 33. Thanks, Spider. I just thought I'd stink it in while I could.
That's fair. Anyway, I will see everyone in the next video, between you and me. Thank you for watching. And
bye.
Let me play a little outro thing and go to.